Today we are beginning to explore the beautiful and deep world of mathematics. You may be wondering what mathematics is and why it is so important in our lives. If we see mathematics, that is, mathematics is a mode in which we try to understand the numbers, shapes, and patterns. We can also say a universal language because whether we are associated with engineering, from finance, or in place from any field of science, this is a common tool that works for us to have major analyze and predict. The first word we try to delete here, mathematics. Mathematics is a systematic and logical approach that allows us to recognize the patterns, to understand their roles, and remove new components with the help of those roles. It has a second concept from the simple to music. The illustration, which means that we show the real world's things a little by simplifying in symbols and numbers so that we can easily map them. The third and component concept means a pattern of two or more. Regularity or operation between things that make us understand something new, whether it is veneer made on the foliage or by taking care of the turmoiled graphs of the stock market. We are able to decode these logicalities in every culture and civilization. Mathematics have their own unique history. It is the pyramid of ancient Egypt, i.e., where the geometry was used, or Indus Valley civilization, from which we get a glimpse of the early measurement systems. The use of maths has always been at the forefront of humanity. It is also so effective because whatever you have to build a bridge is to design a mobile network or plan a space mission. All we need is accurate calculation and patterns recognition. That's why mathematics are also called the foundation language of our world. Now, when we saw broadly what mathematics is and where the usage is, the next question comes to how we can apply it in our daily life or in our future ventures. In the next parts of this video, we will try to find the answer to the same question. We will see that we will find the daily life, how to use mathematical thinking and methods and everything from small tasks to large global problems. Now that we have understood that mathematics is a kind of universal language, the question arises how it works in Iapuata. We have to design a building or plan to deliver the rockets to kill the scientists. A systematic approach is needed for all tasks to clear our question. Define, then break it into small parts and solve the mathematics. There is only one Jiria. Here is another understanding of a two instant terms. The first algorithm that we can say the step-by-step process or set of rules. When we use GMS for navigation somewhere, the back algorithms are working, which show us by finding the lowest effective path from shortest route or traffic. The second concept is the model of you, whether they are forecasting or any stock market analysis, make a mathematical model. We simply, with the help of real worlds, complete equations from the model, we can judge the navigational urina or any prevalent up or down. And the third is the fundamental concept proof, means a logical chain of argument that we show that sign is 100% true or not. If we look at the first deposits in mathematics has in any overall brief for the scene of the modern space today. How did Newton begin to understand? If we try to understand, he had the challenge to understand the planetary motion and gravity in detail in front of him. He and Leibniz made concepts such as derivatives and integral in his own way that we could understand the continuous change. All were the real-world challenges that led to new paths in mathematics. Now how many things around us are linked to algorithmic models and proof, whether you are shopping online where recommendation issues work or you are paying online where advanced mathematics for encryption and secure communication. That's why we can take our problem-solving skills to a new level instead of running away from mathematics. Module 1: Foundation and the Nature of Mathematics. Mathematics, i.e., mathematics we can see as a kind of language we speak every day and writes like Hindi, English, or any other. But why mathematics is being uttered to languages? Indeed, we mean a systemic medium of expressing idea, thoughts, and concept as we have our thoughts in Hindi. As with the help of the words in the mathematics, we put our thinking in front of the world with the help of symbols and reproaches. The language is so powerful because it is universal, whether you are in Japan or the definition of the defective in India can be different, but 2 units 4 are written and understood in the same way. Mathematics are used as a descriptive tool. We can express those patterns in the mathematical terms wherever patterns look in the world around us. Let's say a spiral shells, if we have to tell us about the beauty of its shape is to capture the compact details, we use the rollers of the geometry. Inside the spiral shells we find patterns such as the golden ratio or the finest sequences that show us how deep the movement of the mathematics in the nature is similar to the sound waves that we hear from the speaker. If we plot on the graph, then it will look like a wave that we can say a sine wave. All things are possible because we need a symbolic system that nature enter. It's quite difficult to catch the patterns in an effective way. If you have to tell a spiral shell just like how you'll speak is a bit round then slowly opens. It's small back. But as soon as we bring some of the terms in the language of mathematics, we can differentiate with the help of that spiral's angles, radius, and equities. This leads to an advantage that we can not just tell as a statement of that shape, but also make calculations, transformations, and preferences on it. That is why mathematics is a living language. He not only captures the pattern of our environment, but also predicts what can happen next to those patterns. This symbolic nature is very important of reprobate in mathematics. The concept of reprobate means how we write an idea in a symbol, such as when we say to f 3 equals to, then we are writing our purpose even not just in words, but in a symbol and symbolic expression. This reprobation is therefore powerful because at the same glance is known that there is an unobligatory to. There is a term and the sen is our result. It is a universal approach when we swell it further. All the mathematics and students can see and solve this representation at the same glance is why they are not from any country. Another interesting aspect of mathematics is its logical structure. Like every language, it also has its own grammar and syntax as we use especially the words to create sentences in Hindi. Similarly, we have to follow the roles in mathematics. These roles are called aegeus or pollites. The foundation that we believe without proof is a kind of foundation on which the entire building of mathematics stacked as you see pollites of Euclidean geometry. The straight line can be drawn in between 2 points, or then the right angle is 180 degrees when we get into a triangle. In the equilibrium geometry, all these puddles we take in advance and over them make a chain of the theorem lemma and coral reefs. The most structure that is formed gives us a well-defined language system where the scope of the mistake is greatly reduced. Because everything is based on the logical consistency, if another examining is a sign of plus and addition in the symbols of our maths, what numbers or variables are next to or behind this sign? We understand the grammar of the language if we say that 2 times equals 5 is clean, but if we write that 4 2 3 units will not come into understanding. This is the grammar violation, as in a sentence we add random words and we can write a meaning Matthew. News of the video's advantage of being a language of mathematics is that it poses universal communication without the Japanese side as the linguistics and an Indian side as can calculate your proof in themselves if their meaning is the same mathematics. He said that mathematics is the universal language of science is the same. You can reckon whether is NASA is sure we do our to speed and or calculation in the same mathematical framework as in computer programming. We can use mathematical languages to dissect all the phenomena of the real world, just not limited to the same. With mathematics, we can also see a lot of diverse dialects such as algebra, geometry, calculus, probability, topology, and further advanced fields as well. In every single discipline, we use different symbols and notes, the same idea behind how we can capture the real world or the world's patterns and the right future about them. All of this is the certainty of this into this. We deal with the little that we can believe it and read it in as soon as we say that is like the harmful timbers to know the food that runs on and is only to understand the grammar and repeatability. An obvious next step is that we look at the most simple building block of mathematics, which is counting. Counting is a foundation process without which we can't create any complications or models. From counting, we took the first step on the ladder of mathematics, whether it's the first interaction with the telemarket or the people of today's modern times that are advanced computing, whether you've come from any background. In early childhood, you've learned the same. That's how 1 to 3 4 so on speak. But when we talk to mathematics, counting isn't limited to just counting. This gateway is on the side of all operations of the magnetic, such as addition, subs, multiplication, and division. If we stay in a supermarket, then we have to manage our own budget. We must know how many money we have taken, how much money we can take, and whether our expensive are not more than our budget. All of this is possible from the base mathematic if we are from the concept of count or addition. If you're unaware, it's hard to work well. A very interesting historical snip of the onset of counting is that it was by using telemarks. In ancient deposits, when people didn't have sophisticated number systems like today, they pulled a simple line to record at 2, 3, 4. Every single line reproduced an item or a cow, buffalo, or a bag of granule. When 5 items were made, they pulled a horizontal line so that they are aware that a bundle of 5 is compliant. This telemarket is the most outdated and most straight sort of counting. Gradually, as civilizations went ahead, similarly, our number of systems departed as Roman numerals, then Hindu-Arabic numeric systems, which later became the global standard. Now when we talk about the arium, first of all the additions and subs are learned. You see that both operations we are doing all the time. Sometimes how many money we're withdrawing or adding to how much we have to buy. Our multiplications takes up where we try to repaint addition fast from the same operation. If you have to redeem 5 times to 4 lines of telemarks, you'll be able to apply 4 multiple B. Multiplication eases every kind of event management, budgeting, and large-scale calculations. We are 2 key 3 from, let's say that we had 2 items and we got 3 items, and total out of 5 multiplication is called 2 times 3. We have 3 groups of 2 items that make total 6 items. All of this conspicuous understanding is essential for our further mathematical growth. If you understand that the repainted addition is equal to the multiplication, you will be able to easily access the concept of calculus in the future, where we take up the repainted smaller changes, i.e. the speed of integrations, or repaint changes, i.e. the basic at least used to calculate the default mammal or total expense. We have to make discounts such as the multiplication and multiplication on 10 of 20. The division needs the same way that a store removes your bills. It gives the items preferences by adding or multiplying the final total. While you have to calculate some or remove the interest, the same fundamental operations remain in place. From counting, we have a number of days ahead of which we proceed to negative numbers, fractions, and decimals. Now, we are talking about prime or positive int. Georges as the first people in history have to track inventory and livestocks from them. Naturally, commonly uses trades the integral, like a kilogram or pep-kilogram or frihin, and sometimes in a formula. We see that the repeating decimals also from the idea of how many complicated the line so that we can handle real-world scenarios like diff or temperature is 0. But all of this is always counting in if we see the mathematical edge in the language we saw how we are thimbles. Representatives do this by reviewing the concept of counting. We proceed from 1 to thr and so on, and through that redemption, we define operations such as plus for addition, minus for subs, s for multiplication, and divide for division. Today's digital deposits, from your smartphone to computer CPU, all of the counting and basic movements. The binary system that runs in accordance with 0 and 1 drives all the digital circuits. Why are not complication computers that run everything at the fundamental level? Addition and regional gates, i.e., and not only have been built up. If seen, counting and basic arithmetic computing data add to analysis and technology. Another interesting phenomena we see from counting is the place value system. When we first learn tooth, it seems normal, but the place value system, i.e., 10 hands, Thujan CTC has made our calculations very systematic. We understand when we compile different newer systems, it is very important to make calculations in Roman numerals. Tricky happens while in the Hindu-Arabic system we can easily multiply the addition subs. It is the beauty of our decimal system, i.e., base 10, that we can reproduce a large number by using the same digit, i.e., 0, to know from a large number. Just shift the place values to the historic one. The trade expended people notice that 100 items, 1000 items should be a robot system for tracking 10,000 items. In the telemarxis, how long you pull the lines, so in the place value system they have digits and positions. Concept developed where every position 10 times reproduces the bigger unit. This approach proved to be so powerful that we are using the same to date. So, there is a kind of counting and arithmetic and butter. If we are good enough, then we can easily understand everything from the geometry, algebra, calculus, and probability. In this session, our goal is to see the concept of counting not just as a mechanical exercise like 5 things counted, 10 counted, but also to understand how much logical and historical development has been concealed. So far we have more focused counting and basic arithmetical operations. After that we will move one step further and see how identification to patterns further enhances our curiosity, such as the day and night cycle of the flowering petals. We see a regularity and we step into the world of abstraction by defining it. Then by converting the corresponding abstraction to further generalization we stand several new mathematical thirsty. There are a very beautiful thing in the world of mathematics that we call patterns. If you look around you, you'll find plenty of such exams where one will look a regularity, repetition, or structure. The pattern means a regularity or consistency between two or more things that we can put in place about events or shapes that come to the future. From the day-night cycle we get to know that after the next 12 hours will be again in the morning or at a time afternoon. The same pattern will be the entire system of our calendar. The foundation is where we define vex, churns, and years. If this pattern is not so predisposable, then perhaps we cannot do so much planning, like when to cultivate or what season will be fine for the journey. Similar patterns can also be seen in small things of day-to-day life. One can be in the texture of the door building. You will be retreated again and again. If you are listening to music, there's a redemption that creates a pattern of curry and rhythm. Mathematics tend to get deeper in everything and try to know, what are the rules of these replications? How can we write these rules in a symbolic or numeric form? And that's why we need curiosity, as we wouldn't ask for further questions about how this pattern is happening and how long the retreat is. We can't remove any general rule. Spotting the same pattern comes from a next-level concept of mathematics that we call the abstraction. The abstraction means placing the real-world basics on a little side to the logic or roles between them. As if you look at the day-night cycle, there are a lot of factors in the real world. The rotation of the sun's position, Earth is the axis, tilt, weather, air flow, etc. But when we see from an abstract viewpoint, we can treat this event like a repetitive bicycle that retreats after a fixed period. We say a rotation occurs in 24 hours. This 24 hours numeric value is an abstraction that comes from real phenomena. Now from this 24-hour cycle we train our entire daily schedules, school timings. Schedule define all similarly in the geometry. If you look at the patterns of snowflakes such as spinels, curls, or fractals, you'll find that snowflake in real life captures a lot of music composited symmetric shapes. That's the essence. We can't macerate an aquatic snowflake every time, but are a general rule defining that snowflakes patterns have seen approximates. Seeds in this way are unregistered that a finite spiral pattern form is formed. Then we are making this pattern an unstruct. Spirals can be reproduced in the equipment and say that the seeds are growing in this way. There will be some variance in the real world, but we will be able to differentiate when we understand this element rollers. We can do generalization by visiting another level. From generalization we try to apply a spatial pattern to a large scope. For the exam you consider day and night bicycle as a 24 hours repeating event. But generalization can be that every repeating is a certain period in phenomena that we speak to. And all the cyclic phenomena, whether it is a swing of pendulum like an oscillation in 2 seconds or radio waves that have a frequency fixed. This is the concept for all cyclic events. Now we can disassemble multiple phenomena from the same formula, whether it is a earth rotation, the back and forth motion of the pendulum, or any vibrating string. Is the power of generalization that promotes our mathematical exploration in every field. The very big role of Q in all this curiosity only forces us to spot the pattern first. Then find any tool or equipment to spell it. As if you observe the stock market's graph. Sometimes you'll notice that some of the patterns are missing as cyclic booms, and rational traders try to define their price cycles by tracking these patterns and then make them normalize by making their trading strategy. This way, this same approach nature finance biology is applied everywhere. You might think is a question of how do we get a mathematical theory from a small repetitive shape or event. Perhaps you have heard about Pfeffels triangle is a triangular pattern where there are numbers in every row. Each number is equal to 2 numbers of the previous row. The first one in the row is the one in the next. After that the fourth, then thought, and 14,641 moves further. It seems to be a small pattern to see when you sprint and generalization all. You begin to understand the binomial from the Fischer combinatrix probability and a pattern of several advanced topic up to calculus, i.e. in a small repainted structure. There are lots of math doors for us. Similarly, find a 7's T3, 5, 8, 13, and so on. Follow a repetitive pattern where every term is next to its previous 2 terms. This sequence you can see in nature, in the sequences of pineapples, in the seeds agreement of sunflowers, or in the snail shells. In land we write in a reciprocating definition by absorbing it off SF of n1 SF of n2. Then we see how natural it impersonates every kind of growth patterns used in financial for extending growth modeling by generalizing it in ratio-based expansions mean patterns. Let us see that in a real world, we capture small root see regulatory recurrency in a universal realm. The birth anniversary of the mathematics begins with the same observation. First we try to expel many new phenomena by generalizing counting and arithmetic. This approach we will further use in the geometry algebra calculus coa. If we will not have curiosity inside us, maybe we will spot so much. We ask questions about why this shape is so repetitive. Why do we return the bean condition after this time interval? There may be a mathematical formula behind it, and when we begin to find answers to these questions, we resort to maths in any form, whether we are looking for a pattern about when we sleep and when we sleep in a daily routine, or we are analyzing the pure alarms of the galaxy as a scientific researcher. Basic idea is a single pattern space and then apply general. Let's say that patterns and curiosity are a fundamental driver to proceed to mathematics. As soon as we have the thinking that we need to differentiate every observatory shent and structures of nature, in a way we enter the world of sets and logic by moving beyond the number as we need to grouping pluses and logical regeneration to reinforce systematically to the smallest detail of the pattern. By the way of the same classification and logical regeneration we try to understand sets and basic structures in detail. From where we open new doors to us music. So far we saw that with the help of numbers counting and arithmetosis our curiosity forces us to find patterns, numbers, and types of numbers. When we think about numbers, it's probably the first thing to do in our mind, but our number systems are not limited to only those positives. As human civilization proceeded, we found that we try to understand the negative numbers and beyond. Why and how to develop this number of different types, and why is it the basic piece of today's mathematics? Integers talks first, in which we could not see positive integers i.e. tooth and soon as well as 0 and negative integers i.e. -1, -2, -3 and so on inculcate the negative number to people in the first deposit. Perhaps the concept of negative numbers seems strange as you cannot see the physically minus tie alls, but where the date or temper below 0 comes to 200 negative numbers go exactly, and if you spend around. If you go to -100, it shows your overdraft or date resolution. The appraisal of negative numbers was a little slow process, but when trading and finance implements, there may be balanced negatives. It is the strength of the integer that we can redefine real-world loss and gain. Rational numbers, permissible numbers, and t-jerseys. Moving forward we need to franchise or ratio-based numbers to redeem quantities like we neither 3 by half or 2 left. When we talk about rational, every fraction of the rational number can be written like p/q, where p and q are integer and cannot be q0. If you are taking 2 liters of milk, then 1/2 liters will have your quantity. Rashtriya has brought our area a step further. Now we are not limited to just a whole number. We can also handle fractures or traditional amounts. Irrational numbers, apermissible numbers. If irrational numbers do this starts, we want to be qualified in the early original numbers that are not expressed as fractions, i.e. P by the biggest exam is the root 2 about which a historical kissa is very prevalent. Pythagorean Sarpers as Pythagore had to think that all of the geometric memes can be written with the help of ratios such as 1/2 or 3/4 or even more. But when he saw a right-angled triangle in which the sides one another, hypotenuse square root 2 was proof that square root 2 could never be written as a fracture. Pi and Ers number is also the original. Pi lets you get into circles as circumference and area, while Ers number you exponential. We look at in growth and continuous compounding. Having these numbers, we saw that nature is not so simple that every measurement can be fitted into a p-back. It opened a new door in the mathematical theory. A lot of phenomena is required to be applied on the thick music of real numbers, where there are a and b real numbers and I square is equal to the -1. As soon as imaginary hears the word, we think there is a phase concept. Persicut's electromagnetic waves, quantum physics, signal processing, everywhere completion roles play. When we introduce a shift from real line to the plane, we get a new dimension of geometry and algebra where rotation and transformation can be reproduced very easily. This is a definite motive of all of these subs when you are probably looking for random additions in the trade. We use negative and positive elements when we head to the circle or Oya phenomena. We understand the irrational numbers like pi, and when we see AC circuits or Oya phase relationships, we, like mathematics, become a multi-layered toolkit that addresses every layer of integers, rational, irrationals, complementive, or consecutive problem. In today's round, we do a lot of advanced mathematics on real numbers and compliance works. Cover the numbers and then extend the compaction real numbers to 2D plane. This spectrum gives us freedom to calculate all the way, whether it's wave analysis. Fractal geometry is an advanced engineering, adds a small detail as it shows the evolution of the historic incident mathematics. A Dysel in the group of Pythagore gave proof that it is a logical contraction if the ratu can be expressed in the fraction. This is the first big of the proof by contraction. Example is considered. This disclosure shakes the principle of all its numbers, as they thought that everything could fit into the ratio or the fraction, and gradually it came to the apprentice that some numbers are erroneal in the rigor, and proof traded in deeper in the mathematics. If you think the signal process in our mobile phone consists of a complication usage, our GPS satellites use real numbers, precision decimals to fascinate our location. There are fringle decimals that come, and if you're taking pandy or half kilograms of tomatoes from a molten vegetable, then there are arithmetical numbers running everywhere. This spectrum of numbers are constantly helping to solve our practical problems, so you'll now have understood that we have the integers renal, and that's why ages is because our real-world scenario has different needs. In every branch of mathematics, whether it is a geometry, algebra, calculus, or probability, important engine runs, which is the logic. If we try to understand the logic correctly, then our entire mathematical reasoning becomes solid. But the logic is not limited to just math. We also use the logical thinking use in our daily life, as we think that if I would work, then what would happen if I wouldn't do? This is the logical connector. Now we'll try to talk on the fundamental mathematical logic. We'll understand that the productions like and logical connectors. It is important to understand what we are doing and how we can implement them by using them, because when we read the proof, this logical framework will make our backbone. First of all, we understand what we understand from the logic is a kind of framework that we can disassemble that a statement is true, false. If we talk about our daily life, we are surrounded by a lot of statements such as if there is rain today or not to take it. We think that this food is healthy. 2ps2 echo 4. Some of these statements easily verify. There may be like 2 SCF or not. Some statements depend on the context, such as food is healthy or not, yet we analyze these statements by placing a logical approach. The relationship between them, see their costs on the effects, and test their triad. In the mathematics, we ask the specifics to the statements that can be defined by the truth value, true or false. This means a proposition is 2p, 2 equals 4, that we can accept as a clearly true proposition. But if someone says this food is a testy, so it gets into the realm of subjectivity. It is not a logical proposition, as the testy can be an opinion or preference. Universal truth, no propositions and their truth value are proposition, that is, the statement that we can disassemble about whether it is true or false, and that we approach from a letter of like PQR in your like P5 is a prime number. This statement is true or false can bring the clarity from math. Actually, phys prime. The number is the statement false, as the 9 is not an odd. All dogs have 4 legs. Can test it with real-world knowledge. Most dogs have 4 legs, but if there is an exemption, the disconnection is different. Yet in the context of the mathematics, we will only assume the proposition when we make a logical depine of its triumph or legacy. In the mathematics, we operate above these propositions as they have to be able to consign. This way, we will not or give them a conditional structure. We use the truth tables to make and clear the logical regeneration. The truth table is a systematic list in which we note all the possible combination of the truth values, i.e., true and false, and see what the true value of the ridge statement is not. If there is a p true, false will occur. If there is a p false, then the not p true is a very straightforward operation. Through the registration, we take the upcoming truth value of the statement only when the second one is the second one. If any of the components is true, then the result of the end will be false, and the connector is false only when both the proposition false are. If any one of the per or q is true, then the pr and q is truce. The fourth music application is also called the f-den q. It is a little trick because the f-den is false only when the truce is and the q false. The rest of the cases is true. The most we will be able to analyze the comply mates, like if we say that the rain will go. The main kind of notice will have it only so it's really true. I don't know if it's so under the time of the walls is not the problem is a man is sign real. Many of the I will be able to revive the notes. This inception lets you know that if you try to get up early in the morning, you will not be able to make an effective lie. The statement went wrong because the issue will only be the false when the true false mean you plan to get up early in the morning. It is not revived on the exit in the actual, i.e. the fall of the false. Only then it will be the cancellation and junction, and we use in a very common proof as you see the statement that the yes, if, jur and x is greater transaction 0 defining that is a positive int. If any of these is a part false, the exister is a big issue. Men's false gets dissipation says x as negative and x as 0 can be overall statements as soon as one part is true. We use these in proof as we say that if x is an integer, x sqa will also be even. It is a mathematical fact. We look at the logic framework and become that transaction q per p the time of an is even and q x q as even proof. We just define this if we find s as even now on s square even if you have turned out to be a contract that shows that our value is either wrong or we have a very powerful technique in the logic of the mistake somewhere. Proof by contraction ridges music. In this approach, we take the aegis that the statement we want to deliver is the false and then see that the logic we get a contract somewhere. If the contraction came, we would have been wrong with the convulsions. For the exam, we have done the rut to ease irrigation in the previous section. The Pythagorean had celebrated that rat is a rational number. He gave the wanted to dep. Then he followed the logic steps and saw that the very strange contribution came out from that part. Because of this contribution, he believed that his until Ajman falls had become such a ratu as Arnold proven. Sometimes we see two different statements, but the logical is saying the same. We call the logical equivalence like FP transaction is the logical equivalent of EFF. Net, if you are not an email address, we can regenerate your mail to the contractor's format EFF. No, can be expressed edge no. T and A. All of this transformation helps us to synchronize the proof. If you are a common human being, see how we can apply this in our day-to-day life. Logic is a reward in every field. In relationships, in personal life, in business, when you plan something. And then, I think that if I save money, I have to reduce the cost, i.e. I will go to the gym or go to the morning walk, RNS I have to go to the gym and follow the diet RNT and all the statements. If we analyze in a very structural way, we can avoid contradiction and confusion. Of course, real life doesn't have everything so much cut and dry, but a basic logical thin process makes your decision making a strong logical spread where logical regeneration is powerful. The logical spread is very common traps. Spreads mean you're seeing that the superficial looks an argument logical. At the same time, it's based on an incorrect amine or wrong step like the concept of the SDR. You would have made the argument and then let them abandon in the setting to whom you make a personal attack of the fatial topic so that the scope of the third fallen logical spreads is very low as we follow the structure. On real life, many people are not aware of the logical spread. They can be missed if you are understanding the logical connectors. You are left with all these traps. Math has always been seen as an expert science. We say 2p2 equals 4 and 2 is absolute true. This is the certainty. We consider the adjunct polyets to be base and then logical step to erase them. If there is a spread in the middle, there may be a crack in our entire 30s. For the example, could lead some polyets in their geometry. Among the points we can draw a straight line. Then they remove all the major results of the plane geometry from the logical steps. All of these results are so long torn because they have no flow of the logic. At the scope of the Euclidean geometry, whether we are group thinking or real analysis, logic guides how to provide or dissipate the series. In computer science, there is a complete field of logic that we design microprocessor circuits. We are defining basic logical statements when we write codes like EFF condition do something, alls do. Now when we understood what predicate and how we manipulate our values from logical connectors, the next step is organizing to the mathematics. We have to classify things number object elements and then default logical relationship within them. From here we enter the world of sets. Without sets we never had the default itself. We can't find what universe is talking about. For instances, if we say x, I, z, an even number, first we have to definite that x from which set the belongs sets of integers, c set of real numbers, or the complemented mens or mining. If we don't define the sets, we'll be running arrows in the dark. We won't know that there is a real domain or another domain. That is why the fundamental mathematical is the most essential topic after the logic. Set and basic structures, where we union intersection most Venn diagrams and Cantor's idea, i.e. the infinite sets, will be explored in this set and their operations. Then we are seen in algebra as iometry, all like the set of points in geometry. Sample space in predictability is a set. At algebra we defend the set-based structures of grouping view-jas of set in a line. The logic gives us the foundation to analyze the mathematical statements between them, to define a relationship and build a proof of the logical connectors and net of transactions, and we can test their truth values by applying them from their complications. From techniques like proof by contraction, we check the validity of the statement cross. The logic is very powerful even in daily life. Whether we're taking our dissipation or media political claim, we'll try to see sets and their operations, in which we'll understand what role of sets from our daily classification to advanced mathematics. Sets and basic structures. If you look at the journey of the whole mathematics as a building, the sets work like its foundation. The sets give us a kind of container thinking in which we can group similar or relative things and work on them as we were talking about numbers. If we say that the set of all integers is, then we give a large group to all the numbers. We can speak integers and work on it. I love logical and non-Greeks. We will try to understand what the set is and what is the role of some basic structures associated with it. At the same time, we will also understand the fundamental operations like union, intersection, set. Then we'll see how the sets concept is visible everywhere, from your daily life's classification to advanced math. The set is a collection in which we put the objects into a group. The bus condition is that there are some real among those objects. Every object is called elementor or member of the set if the object is of X set A. We say X belong to A or X is in A. If you can have a set of fruits in which you put les and oranges, in this set you're counting les as an elementor. Search also the rest of the fruits. You can set off the even numbers in which all of them will be integers that are divided by 2, such as 2, 4, 6, 8, and but all you can think of from the definition of this set. You can see that we also do the concept of collection and membership. This concept is linked to our logical regeneration, as we have to first define what kind of object we want to bring in place and which object does not fit into this groove. The subset means that all elements of a set are also in any other set of whole. If you have a set of A and a set B, and that's what all the elements of A are in B, we say A. As of B. If there's just 2 and 4 in A, B has 2, 4 S. 8A. B will be the subset of A. B that's the already present in 2 and 4B. Let's say a set of all dogs and a set of all curly dogs from it is part of the large set of dogs. Mostly there comes a lot of work in conception, such as you can set of integers and its subset of integer sign. Lee in a small portion defined union, say to mix two sets so that you have all elements to come to the same group. If we have 2 and 4 in the set A and the set B has 4 and 6, the union of A and B will become 2, 4, 6 as we take all the distinct elements of both sets. You can have a set of family members and a set of close friends. Both of them are unioned. You will get together. From the union we can add the category or then the task of 2 projects. The same list can merge so that we have a comprehensive list. Intersection shows the position that is common in 2 sets. If we have 2 and 4 in set A and have 4 and 6 in set B, then their intersection will be 4. You have a set of favorites fruits and your friend has a set of favorite fruits. Both of the intersection will reproduce the fruit that you can have both favorites. This idea is quite practical when we see if the thing is common between 2 categories. In many planning scenarios it is essential. Does the tasks have overlapping in the middle of 2 different projects? There are 2 more operations. Deference and music. Complenos and so a minus is just 2 savings in the B because 4 and 6 are also in the B. In the complement we see that the elements that are left outside of the set after defining a universal set may be the consolidation of your set. This could be very helpful in advanced planning or classification. At the moment we have to sum that from the operation of the sets we have every kind of grouping mergence and overlapping relationships can be different. One diagram assumes 2 round circles. One circle reproduces sets A and the second circle reproduces set B. When you overlap these, which is the overlapping regeneration, he is his intersection, that is the areas outside of both circles. He is the unique parts and will meet both circles. He will be his union. This approach is very straightforward. Classification problems like all students who like cricket and all students who like football. Now both sets we can check the overlap by executing the union check and understand the defense. Venn diagrams is a kind of constitutive map that allows us to quickly visualize the relationship of the sets. Now when we understand this, we define a group or ring. All of this are a set of special types on top of which some operations are different. We will never be able to clear what objects we are talking above. Set basically play a role of our universe of discourse if you go out of the field of mathematics to data science or management. The sets come in handy even when you are having any data handles such as set of customers, set of products, sets of orders. You analyze by removing the intersection or union from those sets. Let's see how many customers are buying multiple products or how many products are just selling in one regeneration. Also, they thinking put into this the infinite sets. He says that infinite is not a single idea. There can be a number of infinite sets. Some sets are countable infinite such as integers because you can list them in a sequence. Some sets are uncommon, numbers that you will never be able to capture a list. Many people were surprised by this concept as we thought infinite is the only infinite, but the canon showed that some of the infinity is bigger and some smaller, or evidence that the consensus through the mathematics philosophy had to shake down. If you want to know in more detail, you can understand about the diagonal argument that the set of real numbers is bigger than the set of integers. Now you can think about what it will come to our work in real life. But if you're observing your routine, you're using sets in several ways, like the first to-do list. Our task is just like a set. There are some tasks that are linked to our personal goal. Some task professional rounds can be tasked if we see the interaction of these sets, which can bring both personal and professional benefits. The second friend circles can be like a set of different friends groups from their union. All of our friends get a combined group and their interactions meet people, which is common in between 2 or 3 circles. Then the shopping category, we have a grocery list. Set of groceries is a personal list near our family member. We can become a final list from the union of both. From the intersection we can see which items are in the problem solving. Too many times we are looking for a solution. If we have a set of possible solutions and another set of constraints, we can see in their intersection which solutions are meetings of the mathematically spiking sets. From concept we can handle the classification, grouping, merging, and filtering subsystematically. So far we structured our thinking set and logic together. Logic helps us to understand the truth value of statements and sets us in defining the domain of statements, like if we say x is a prime number and x greater than is 2, then there will be an anode. First of all, we are condensed in the set of integers to the x. Then we will be the most of prime integers, then we will be chanted in the set of integers. Conditioning is that x is larger than 2, and then we are giving the Volusion statement that x is odd. This complete regenerating structure cannot be possible without set and logic. We have to first define the domain when we prove. That is, set then the conditions, i.e. the logical statements, then we regenerate the statements. The numbers, logic, and sets are the 3 things that our fundamental mathematical things are ready. You have yet seen that the numbers also have multiple types of integers, rational, irrationals, compliant, quotes, true value by default. We can apply and set the next step. We define the classification and membership. We try to get all the things done in a structure so that we can build units and relationships. Here we will try to understand the module tool of break thinking and relationships, where we will see how the problems can solve by redeeming numbers and nons from letter to letter. Module tools of break thinking and relationships. Algebra begins with a large, straight, but quite powerful concept. We redeem our difficulties as a defaulting value. Let's say you're planning a small event like a birthday party or a farewell dinner. You have a total budget, but every item costs. You don't know exactly how many you think will take money for decorations and how much allocate even for refreshments and so on. All of these answers are just unknown for you. Algebra tells you that every unknown can redefine us from a variable like x kick cost. Cost of cost and tight refreshments. You've given these 3 unknowns as soon as the name. You've got to take a systematic shape. The basic meaning of variables is that we have a scope to change the value variables in them. It can also be a value fix, but we don't know right now, so we denote them from a letter. Giving a structure to these anon leads to a tricity in our minds. If we've done the budget B, we can write that the x pav ps is an equi B. A simple equiment captured all the budget scenario into a line. Now we can see different portions that if we know how many cakes will come, we can plug the value of the x and then adjust to the bakes. This concept of algebra is why power is full. One of the reasons why we can generalize how many of the problems with the help of anon, as if we do not just plan the same party but the cost of every kind of events. Whether we keep our equipment in the form that is applied in every scenario. You prepare a formula, and for different events, different values can be solved by adding different values. The biggest merit of this approach is that we do not regrow the entire calculation for every new synchronization but already prepare a blueprint. The idea that we can redefine the unknowns from the letter. First of all, the systemically populated by a scorer named L.K.H. Hormist. Their work came around century in which we look as the birth of Alzheimer's. L.K.H. Hormist gave step-by-step way in his books to how we can solve equities. He also showed our choice everything like x to be considered an unknown. The rest of the new numbers are taken on one side and then the value of n is found by systematically operations. It was a very revolution thinking as the first people were mostly arithmen or depended on the geometry constructions. Algebra gave us a new look that we could tackle the very general projects such as land measurement, intelligence distribution, and trade collections. If you see Aquine is a kind of language as we are listened. Algebra in day-to-day life. In the language, we create units. If we say let x be the cost of one sandwich, then we are giving a statement. Then we say if a by 5 sandwich total cost is 5x, the second statement, and if we have a total budget fixed, we can write that 5x was laces and equivalent to do, which makes us aware that the cost of buying a 5 sandwich should not exceed the same. Keeping this systematically at the same place clears everything in your mind, and this clarity is the greatest gift of algebra. Musical algebra is not limited to just daily budgeting but also opens a straight way for higher mathematics. When we edit a pattern such as squares, cubes, series, or growth rates, then we can write all of them in the Juin of variables and annons. What do you want to model population growth? You can find new units with let PB's population R be the growth rate and T be time. New equipoise is a simplified example and then can solve it. It is a simplified example, like a very large scenario. The epidemic spread resources allocation physics' motion questions can tackle all the historicals. The book in Elkavar is taught the method of solving the problems from a very direct approach. He told the stepwad that you delete the term on this side and shift the square root as simply. So it was a robot that we teach our new version in schools and colleges in Europe when the Latin translation of the book came from algebra's word. Descartes and the rest of the mathematicians further explored algebra with the link to the variable to the coordinate geometry and added to this incorporated into the law of mathematical fields so various songs and nouns into the validity in daily planning. You will also need to make it further imagery to plan the space mission on how many variables you have to do. Rockets and teal velocity, fuel congested, and how many things you just don't know the exact value from the algebraic framework. Factors can be brought to the same system. Then they have a very wide application of solvents or approximates. We have no definite way to tie and thicken together in a way the equipment symmetricalizes our story. Annan plus Annan plus Annan plus Annan equals total is a story where Annan is our character and total is our concussion. This approach when you do in multiple equipments and multiple Annans, like you have x, y, z, 3 variables and 3 relays between them. You can remove the value of the 3 unknowns, i.e. we can find 3 different types of devices that are treated together. In real life we say that our resources are so many, our constraints are so many, and our rounds are so we are solving an multivariable system is kind of multi-constraint and multivariable problems without Alzheimer's handle makes it very difficult to handle all deposits. People tried from geometry, but from geometry you don't always find out the exact ancestors. From algebra to we on the pen paper, the appreciation can be manipulated and finally removed. That is when we say algebra is the language of mathematics. A large part of it is variable and unnoticed. Every advanced field, whether it is linear algebra, abstract algebra, calculus, or probability, is incompetitive without all Alzheimer's expressions and equities. In this way, we start with a real-life cover to the legacy of Alquim and then in the modern multivariable system. And when you understand this concept on the concept of annons, you are in a powerful position. You can take any new scenarios. Players can convert them into variables. They can differentiate the relationship between them and then solve the equipment. After all, we move to the next step where we talk about the functions. Functions basically teach us how a quantity depends on the second quantity and how we can surprise that dependence in the same expression as soon as we consider input to a variable and output the second variable to us. The analysis becomes very systematic. One step ahead of the world of variables, we come to the beautiful concept of this function. Let's say you have a machine in which you put an input and no output from the machine. We can define what process is running inside this machine, but we just see what input went and what output came is the idea of the function. We say the function is a rel or relations that output every input to one assigns. Its most simple exams can take you from a daily life with temperature conversions. If you're having temperature in the Fahrenheit, your function can be temperature and output Celsius. As soon as you input the number of Fahrenheit and use formula, you take out Celsius. This formula is F32 multiple B5B9. This is our function. We can give a name to the function like T of an equivalent minus 32 multiple B5 Bana, i.e. this function works as a convergence machine in calculus from T. Fahrenheit. If the price rises, the quantum demand is reduced, i.e. in the function you can opt for a negative relationship. If you're looking for population growth, the time can assume the input and the population will increase the output time. The value of the population will increase as no function linear will ever follow the expirational or ever complication. It's all real-life exams that are all real-life exams. The concept of function directly decrypts the mathematics. We space two things when defining the function. The domain and range. Domain means the set, and range of our input values mean the set of possible output values. If we talk about the temperature conversion, then the domain may be the values of the Fahrenheit and the values of range C. If we talk about the supply-demand, the possible value of the domain price is and the possible value of the range demanded quantity. We find a very structure by making the space V. What inputs will exact and what outputs can give. We can think that we put an input x and the function gives us an output f of 1. Here is the name of our function and redeeming our input. You can visualize it like a box diagram. The visualization will be helpful because if we look at a problem from the perspective of the function, we can ask the directory how much the output will change if the input will change. This makes the problem solving quite systemic. If you take an exam, let's say that if music consumes 500 extra calories a day, how much your weight will increase is a function input. Your extra calories and output is weight gain is making a direct relationship. Ages that we see a formula i.e. approximates functionalities like a machine can input into learning model. Features of a house such as bedrooms can be bathroom location and output predicted price, i.e. function approach is used in very advanced algorithms like fundamental building block. Another way, if we think our stock market trends can also be understood by the function approach if we will come to the stock price output if the time is input. This function can be a very unpacked force function that has a lot of external factors, but the concept-wise we can think of the function between time and price. Sometimes we talk about multiple inputs such as the temperature, humidity, wind speed can be all inputs in the weather forecasting, and the output size of rain can be. Then we can think of the multi-input from single input. On shifts, the idea beans remain that we are defining an output from the set of every input. If you take an exit from the set of a small box in which you are putting the raw potatoes and the machine is pushing you out by giving spicy fries, this is the core of the function that the input gave it to a new form in the output. If we take this transformer by defaulting a formula, we carry a formula function. Sometimes this transformation is very straightforward such as multiply by 2 and sometimes a very compaction model. When we go to the higher levels of mathematics, we remove derivatives by adding this concept to calculus. The function is a very flexible constipation despite being so fundamental. We can define a function in the discrete now as mapping between cis-parametric forms in geometry is and in all of these is a limit in handing you the in real analysis. If you look up these up for a mapping by moving a little further from the equipment before we said as we now say given as fine or in eta can become our function where we get output from the input as if we take the same exam if the budget is in as we can make a function different by a input is output. It is very straightforward, but we understand it. At the same time, the function told us that if you put the cost x of the cake, how much the cost of decor will be so that there is no extra from the total b. This cause and effect thinking that comes through the function. Real life has a lot of work. If you are in the ting, you will think that if I increase the advertisement spend on 10, then how can the sales grow? This is the direct function approach. If you are in the environmental studies, you will think that if the pollution level is so much, how much defense will come to the average temper? Again, a function approach if you are a hobbyist. If you're a gardener, you'll think that if I do so water and so sunlight, how much is the task in place? Just we make it custom defined in every domain. Now when we do this approach, the next question comes to how we visualize this function. It's sometimes tedious to see every relationship just in units. If we plot the input axis and output axis on a 2D plane, we can redefine all the positive input outputs of the function to the point form. That's what graphs. From the graphic function we can see at the same glance when the function is being incurable when decrees are getting to which point can come to maximum or minimum or any intersection which is happening from the second line. The graph basically is a visual summary that gives us or more intuition than formulas. So we are going to talk about the spatially graphic interpretation in the next section. We will see what the slope is, what is the intercept and how we can apply these concepts on stock market graphs or health tracking data like real-life exams. For all this analysis, we have a basic knowledge of the coordinate geometry is quite helpful. Graphical interpretations. So far we learned to write the equipment by defaulting variables, then a input-output relationship to those units from the concept of function. The next step in Revenge is to plot these relationships on the graph so that we can see their shape and gain more insights about them. The graph is a kind of picture that helps us to immediately understand that the function is going upward. The downward is linear, or the cyclic is a lot of things that are hidden in the equation are openly in the graph. The most common approach is to plotting the graph. The coordinate geometry, defining the axis and vertical axis to a horizontal axis. If our function name is we plot a horizontal axis and f the value of the of 1 is to make a point for every possible x, then on a vertical axis with horizontal coordinate ace and vertical coordinate f of 1. All of these points will be connected to a line, curve, or shape, then we get a complete graph. It seems very straightforward, but the same approach stock markets, weather charts, fitness data works in all. If we take a simple exam, we say that y2 a platform 3 gives means a function of s for every s to put 2 times x and add 3 to it, because or every 2 is a platform 3. If you place s equal 0, then every 3 if s equal and place tove every 5. If you have an equiv, you will see a straight line, and if you play all the points in the graph, there will be two interesting things in this line. The slope, that is 2 in this case, and from the slope we understand how much the line is going up or coming down. The second will be the interjacent, which is in this line. When x is equal as is a 0, what is the value of the value? If you look at this graph at a glance, you can tell the intently how fast the slope in real life gives you a sense of rate of change. As if we talk about the time price graph of the stock market, the slope tells what speed the stock is growing or falling. If the slope negative means the stock price is dropping, and if the slope positive means the price is rising. If the slope is very fast positive, we say the price is shooting up, and if the slope is very fast negative, we say the price is crashing. All this visualization itself tells us the story at the same glance about the data. That's what we can plot our daily steps count with time. Place day numbers on x-axis and steps on y-axis. We can see which day our steps are very low. Perhaps on weekends we get legged, and which day are maximum. If you want to see the slopes, you can understand what speed is happening by a day-to-day increment. This approach health tracking apps use when she shows in your heart rate or sleep pattern graph. At the same glance, you'll find the idea when the peak came, when the troughs came, and what the average is going on. The graphs are not limited to just straight lines. If you plot the or the equivalent times is the power x, you'll see a curve or they get rid of the is rising. Depending on b greater transaction 1 or less transactions and population growth, we see curve compound interest also has a curve I. From the graph you can see at the same glance that the initial growth slope was on a point after the curve became very stepping, so that we understand how exponential growth can be over explosive. Sometimes we see cyclic patterns such as sine wave or cos wave. These shapes show you a lot of space. Sound waves, light waves, seasonal temperature changes, and lots of other phenomena graphs from you immediately recognize that it has a repainted pattern that is repainting on every certain interval. If we look at the numerical table, then maybe we understand that this is the cyclic function that the graphical approach is so popular. The pattern is very easy to recognition. If you go into a little more depth in all of these, you have a basic understanding of the coordinate geometry where we define x-axis and y-axis. There are two fundamental things in which there is an intercept and slope, or if there is a curve, we can define things like tents and curvature. All of the advanced concepts will give you calculus. For now, it is quite important to know that there is a line or the curve. We can analyze its instant points from its steppiness and its interactions with a very relaxing graph. This allows us to find solutions for units if we plot two functionalities and see when both are equivalent. We look at their interaction point, i.e. graphically we can find a lot of difficult actions such as a solution approximate or agak. Sometimes we learn more details in the coordinate geometry as an alternative deep dive. Point formula, slope formula, and conic sequences. It's all the topics of the very work, but it's important to understand that we're using graphs like a tool to visualize a relationship, no longer be able to go into more detail than slopes or intercepts. Yet you can understand a lot of things from a rough sketch, like what the trend is, whether the pattern is cyclic or linear, is a growth slow or fast, and can be a function negative at a point. You can take real-life exams like a stock market or heart rate monitor. In the stock market, you plot the daily closing price in the y-axis and see the days on the x-axis. You can see when the price spike came, when the drop is, and how ruffled it is. In the rate, if you plot the data by minute, you can see when your heart rate was the highest, perhaps the time of the workout has been, and when the lowest it is. All you can see in the columns of numbers on the graph that the direct insight is unmatched. That's why visual data analysis in a lot of scientific and F feeds so much. It is important that you will see raw data. It may take a lot of time to spot the pattern. So you will see time series charts, line graphs, scatter plots in books, news articles, and reports. At the mathematics we form all the approach as the coordinate geometry on the actual use is common in every field. So far we saw that we can create units by treating variables like anon. Then the input-outputs can understand a relationship and plotting these relationships by graph. In the next session, we will talk about the triggers in the center by furthering the algebra thinking. Here you will see how to model the basic equipments in the inclusive real phenomenon, how we can assist the equipment, and then the most interesting thing is that we find all the additions to art divine physics and the structures and sundry basic equipments in quality and models. When we talk algebra tires for aids like linear equations, quadratic inequities, or any other practical life, every synchronization is not just a sign of a part A from a sign of E equals T. We need to apply a constraint where we see that this value cannot be so much. The thing should be at least so much. All of us expressed through these equalities. In this section we will see how it works in modeling linear and quadratic equities real phenomena and what these equities play in our planning and constraint-based rewards. Linear equipment is one of the most frequent forms we saw initially in the linear model in every typically free real world is that then we celebrate that there is a direct relation between two points or relationship of tensor rate if we say that this is equal to speed multiplied dy time to the only linear model the distance renders linear in the monthly here in its own time. If we have to find the utility cut on this rate plus then form a linear equipment then that we regard that everything is linear. If you see that a thing is getting extrad or following a curve, then linear equipment will not work there. Quadratic means an equipment in which x squares term is a practical exam. This is a projectile motion such as you throw the ball or shoot water from a fountain. Their trajectory rough creates a parabola. This is the only graphical shape of the parabola quadratic. If you plot the distance in the x direction and plot the height in the y direction, you see an arch shape. Fireworks of ballistics and bridges quadratic relationships are seen in the design of the arcs. Inside the quadratics we can also remove the rotes such as where the projectile will return to the ground or which one cuts the parabola x-axis on 2 points. We can outtime a flight or range figures. The very straightforward approach is to remove the equipment by solving. Now we come across many times the evidence say that orbit 9 10,000 the alpha evidence they say at the FDI now would do 100 so it means that in the world you have more than 100 at pava yesterday at 100 they has it is very hard that finance for is with the fans the wiki the hard limit. If you are planning a diet, it will be said that caloric case conversion and equivalent to 2000 i.e. you don't want to let the total caloric calories be more than that. In the equity, we are defining a range in these equity. It is more practical when we set a limit or keep the attest condition. That's what we see when we take a loan. The bank holds the condition that the monthly income takes the greater transaction and equal to assume that 3 times E so that they know that you can afford. Equity for planning and constructs is a very fundamental tool if you ask what exactly is a defense in real. When you sign the equivalent and when the greater transaction and equal or less transaction and equivalent to use it all dibs on the nature of your problem. If you need a precision output like how much the distance will be, you have an equation. At distance equipment speed into time, if you're defining the constructor as I have to keep less than 10 kilometers of time, you'll use these equity. By combining both of these ideas, we can solve the real-world problems. In many scenarios we see a combination such as in production planning you speak a relationship between total items produced i.e. X and total hours work i.e. W. X cannot exceed warehouse capacity or Y cannot exceed 8 hours a day. All this one system of equity plus becomes inclusive of which we can solve from techniques such as linear programming, but the same basic concept in every foundation is linear or quad equity and equity. Similarly, in the environment you talk about the pollutant levels. Standard norms define that the pollutant concentration easy transaction and equals to equimize force limit if it is limited cross alarm for us. Mathematics is integrated everywhere in our log poly and planning all in this way. Just express them and we accept and as equalities. So far we saw that we can put 1 or 2 variable relationships into linear quadratic or in equity form. You will see that the symmetry in mathematics is a very powerful one that takes all of these forms to the same umbrella. Whether you're looking at the symmetry of shapes in geometry or looking for patterns in algebraic expressions, the symmetry will get you everywhere. In a lot of natural phenomena you'll see the symmetrical patterns in Leb's crystals and Elvis flecks. In the form of transformation can define the symmetry we all like. We see if one likes one of the shape left and right sides, we find that visually appealing, but the symmetry in math is not limited to just aesthetics. This is a very deep concept that we can disassemble the pairs. Transforms can understand and define and sees the fundamental laws in even advanced physics and chemistry. If you say in direct terms the symmetry means that if you have a shape with some operation such as flip rotation, after that, let the shape replenish itself, we say that the shape is symmetric. A basic exam can be a circle. How much you rotate is the map in itself. So it is infinite symmetric. The kaleidoscope consists of color by color glass pies and the mirrors make a symmetric pattern by multiplying the reflexes of those pies. Symmetry is here in the form of a reflection in this game. In the case of Rubik's Cube, you can rotate the cube, and you ovulate that in some confines colors are lined. All this rotation is the symmetry. When we come to group Phi, we draw the formula how these moves are a set of transformation diamond salt sugar. All crystals have a repeating pattern. We can think of these patterns as a symmetry regiment where the unit becomes a complete crystal by repainting cell. This repainting symmetry gives crystals the properties of their hardness or shape. Group in mathematics is a structure where we take a set of elements and define an operation beyond them, such as rotations or reflections, and see that these operations are never over. Every operation you can apply one after one and all of the resumes remain in your group. It may seem quite unstretched, but in real life, the kaleidoscope reflections, Rubik's Cube rotations, crystal symmetry is defined by all group theory. You can think that we have a list of transformations and let us know the rules to combine these transformations if you do the second rotation after a rotation in Rubik's Cube. The third rotation can be the same group's closure property. The symmetry is not just a physical games and nature. We see that architecture is also always found to be the symmetry, like Taj Mahal's reflection Hoar has people consider symmetrical patterns as a static pledging. Reflective symmetries are very common in Rangoli or mandala. Mathematics are involved in all these things as when we say that the mirror's rotations translations we are applying only from the concept of group theory. Just artistic advantage from algebra to when we solve the equivalence. Sometimes we see the symmetric excitations such as x square plus or square equival r square, which defines a circle. This is the rotational symmetry of the circle. In quadratic forms, you can sometimes remove the symmetrical path that simplify the solutions. At a much advanced level, you see that the inventions in the physics lodge come from the symmetries such as rotational invariances are not a depend on the transnational invariance Newton lodge time or are not a depend on the direction. Translational inventions is all the same underlying idea that the system promotes itself even after the transformation. Now we've seen how the seminary is the game of crystals. Now in the next section we'll focus on another practical scenario in the next section of the system of equations that you'll find in the daily life schedule, resource location, and blending problems. All of these things we try to understand how to make the simultaneous solvent. You might have thought that when we've been more than one of the unknowns faces in real life, there are multiple relationships between them and how we take out their values, such as how you are planning and restore, how many tables and how many chips are to be weighed, about how much staff should cost the head. All things have to solve at the same time. This is the system of equities where we hold x, y, j, d, etc. like multiple anon and a multiple construct defined between them. Simultaneous equipment means that we have two or more units that have to be treated together. The most simple is the first as about equi 10 and the second as minus or equi 4. If you solve both of these together, a unique solution is found in SC7 and NW that we 3 real life. If we redeem S to nopes and W and we have two constraints, total items 10 and differentiation 4i. Expel E10 and ace me the E4, so we can figure out from the same equipment how many nopes and how many pens will be. The exam is very small, but you can see the imagery system from 10 resource planning cost analysis can all think you want to do an office meeting room scheduling, how many of the team needs to come to a meeting, how many rooms are available. All of this can be inserted as the constant system of equities and inequity. In manufacturing, we can say that the product will take 2 units of raw material, 3 units in making product B. I have a total of 30 units of material. It can be an equipment or inequity. Then the fabrication of the labor hours. The distribution cost can be a constraint of all the combined hope becomes system by solving me find the best combination from the irrigator to cooking. We always use the system of equipment in the blending problem. Says you want to create a fertilizer that needs a nitrogen, phosphorus, and potassium, i.e. the search ratio of NPK, and you have different raw materials whose chemical composition is different. How many units mix raw materials so that the respect agent of final mixture it turned out to be a multivariable system. Simple things you see: coffee blending, fuel mixing, and chemical production in all. We find it difficult to solve manuals from pens and paper. Here we use matrix approach. A matrix is a rectangle adjustment of basic number that we can solve system of equipment by operating. You can note the efficient as a table. Then we can find solutions from cry operation. This is done through programming and approach computers where we can solve system of equipment. Solve very large systems such as simulation, data analysis, machine learning is the use of matrix operations in all. You saw in the previous section that Rubik's Cube has a transformation. In the advanced math, people track the moves of cubes from matrix reception as a rotation can be written as a transformation matrix, i.e. both system of equipment and transformations are handled by matrix approach. Any organization, bank, is hospital or factory every day with multiple constructors and variables. There may be handles in the spreadsheets that are using or any specialized software on the fundamental principle is the same system of equipment and the same of these equality. How many of you can keep an application for how many of the products are targeting for the surplus? All this simple news solvent is used every day in our life. It is simply hidden in the form of spreadsheets and software. Module 3 Space Shape and Visualization Geometry and bead lines, angles, and simple shapes are the direct beginning of the geometry, the most basic elements from the line, angles, and simple shape. If you look carefully, then every outline of the whole world is designed and every structure is formed from these small things. Take a look at the roads. A lot of paths are intersecting from each other. Some of the paths have a sharp turn, i.e. a single angle. Look at the wide turn, i.e. tug angle building corners in a few. There is a 90-degree angle that gives stability to the structure. We look at the side of a simple daily object like a cardboard box, see that the line segments rectangle. The faces and right angles are composed of the most basic concept. In the intermediaries of the line we consider the line to be a figure in which the direction is, but there is no thinness. In real life, we show the edge angles of the approximates to the turning between the lines. If you join the two lines on a point, i.e. the vertex that the major is formed, we call the angle. Majors we can take the degree or sometimes in the radian. The 90-degree angle gives us a lot of commonplace, whether it is the corners of the notebooks or the furniture. The edge is now polygonal when we talk about simple shapes. Polygonal is a closed shape that consists of line segments such as triangle, i.e. 3 sides, quadrilateral, i.e. 4 sides, pentagon, i.e. 5 sides, and further infinity. If you ever try to make a mini house from cardboard, first you will cut around the rectangle pies, i.e. the walls, then add them to the angles for a triangular grinding roof, then your structure will be formed. This small activity can give you a real sense that the geometry is not limited to just books. We will cut every day. There are angles in polygonal, but they reduce notice when we see the properties of these shapes. We notice that angles are side lengths and parallel or perpendicular lines define a lot of things such as stability, design, aesthetics. If you are creating a shelf, you would like to be a sales hustle at the floor in the side vertical perpendicular floor so that the angles that are little wondering then the shelf will not be te. Triangle is one of the most fundamental polygons. If we have any, we can split it into small triangles to remove area angles or honor measurements. Triangles in construction, architecture, and engineering are very important because it is stable shape. You might have seen bridges structure has many steel beams. Triangular patterns have arrays that increase their strength and stability. What is the significance of angles? Suppose you stand in an open field and you want to walk a straight line. You can take a compute like a reference to the direction defining. Contact us how many degrees you will have in the north. Whether you use GPS, ship, cell, or plan a building, it becomes very difficult to define the direction without an angle tabler. Sometimes we count the vertices, i.e. corners, and edges, i.e. line segments, to define the shape. If there are 5 variations of a shape, it became a 5-sided polygon if it has a 90-degree angle on a vertex. We will probably classify it in rectangle or square if the rest of the condiments are matched. This classification proceeds further by our geometric reasoning makes it easier. We can remove a shape properties like area, perimeter, direct formula if we know what the shape is in real life. How much we deal with such shape if you are ever doing home renovation. You note how much the length is and how the angle is on the corners so that you can disassemble the speed limit from the turning angle of the roads to fix the tiles or wallpaper. If you see in the sports the football pitch is rectangle, the corner. Arcsin is based on simples. The cricket ground may have a boundary circular or elliptical that we go to see the approximates music angles and basic polygons in the form of geometry. The concepts of circles introduce and see how these shapes are added to real life such as the world of basic calculation. Polygons such as triangle in bronze, circles in gears, and perimeter area is very interesting. Triangle, quadrilateral, pentagon, hexagon, and how many sides can become shape. The most visible polygons in real life are rectangles and or squares. It will be on top. Rooms, doors, books, phone screens are all rectangles, but if you ever ask the curiosity why we prefer the rectangle structure, a resonance is that the rectangle corners become energized for us. Majoring plus space uses get confectionaries. Many times we use the triangular structures so as they are stabilized as it can see in folding. We count the utilities of the triangle very much. In specialty engineering, you can see a bridge. Triangular patterns are created in its framework as triangle is a resemblage shape. If you take square, pushing the 2 subordinate corners into it can make the shape a bit distort, but how much force you put in the triangle is its angles and side lengths stabilized. A lot of load-bearing structures due to the corresponding property have triangle frameworks use. The circle is also very unique shape where all points are from the center to equivalent distance. You can see the circles in wheels, in the clocks, in the gears, and in how many machines. The same is that we use the wheels for rolling. In the circle there is a judge uniform, so the shocks in rolling are low. Some of the basic properties of the circle have to be defined to us such as circumference, which is the length of the boundary of the circle, and the area, that is the area inside the circle. Both of these come to the pi constant with the approximate value of 3.14. The approximates of the historically pi Bologna and then the Archimedes in different ways. Gradually it was clear that pi is not a rational number, but it is still important in our computing. We use it from an approximate value like 3.14 or 22/7 or 3.14159. You can see in the constructions, if you have to create a circular arch, then you plan around the circumference formula, i.e. 2 multiple b pi multiple b r, or area formula, i.e. pi multiple b r square, is a major defense in polygons and circles. Polygons are made of line segments, small straight edges, while circle 1 curved boundary is a polygonal with approximates from the polygonal and it seems like a circle. Different if you're bound with polygons from a piece of the from the pairs of polygons to a circle circumference with me if you enter the fencing to beyond you have to remove the boundary with a burn rate rim within off in the burner formula with multiple level the be circular the certain theories who multiple history if you're here all fundamentals of a negative flare. If you are painting or floor tile, you will apply the paint or tiles from the area. About the triangle, we saw the bridging angle. When you think the gear in the circles of the examples, every gear is the same circle on which the teeths are created. When the two gears are interlocked, their circular edges push each other and the rotation transfer occurs. If the gear circle is not perfect or the depth missed is matched, the friction increases greatly and the gear as a result. The circular accuracy in mechanical engineering is one of the most important elements in mechanical engineering. The story of the pi that we say is that the pi is transit means a number that cannot be a compact solvent from the old brake equipment. It also shows that the circle is a kind of perfect shape, which is the ratio of the difference by diameter we can never express in the simple fractions. Yet the pi in our day-to-day calculations, i.e. 3.14 or 3.14159, works very much now in polygons and circles. We saw the basic geometry life and their real life. We also explored the obliques. We will combine these shapes with a position that we call coordinate geometry. This allows us to plot the line angles and curves on a systematic X or plane like we created graphs in algebra. Coordinate geometry created a bridge between geometry and algebra. The first geometry is limited to poorly shaped angles and constructions and cut related to algebra and in any case. In 17th century he given a resolution idea that we reproduce every point like an X or a pair where there is X and or two real numbers. From this approach we find a line circle or a polygonal algebra equipment that you draw a D-plane. Horizontal axis is called x-axis and vertical axis is if you have a point of 3, 2, then it means that in the direction there are 3 units and 2 units in the direction. This idea may seem very basic if we have every shape of the geometry. Coordinates can be brought to the form if we say that the circle of radius r, then we can write as equation x escape have sk equal o. If we say that the line with slope a and intercept c, then we can take an understanding of the zolo plane to the dantu longitude in y equals mxbs. Then we can check with the distance formula how far the 2 points are, or we can make a route plan. When you want to move a robot in robotics, you x your position w or kawa z. Defining in coordinates you can define an angle orientation and then generate a path. If you see in the astronomy, the position of the stars and planets we track from the coordinate. If we have a planet, we can set up we can see all of this is very unstructured without the coordinate geometry. In the coordinate geometry, and there are things like the intersection. The slope basically shows the line's steepness. If the slope is 2, then the line will go up 2 units on each unit horizontal move. From the intersection we see when the 2 lines are crossed. If you think of the 50-20, you can see where the train intersectors fiki the coordinating of the roads in the city planning. We can pin that identity and the good things be time or distance time related are very much to be those filters over the function that we need the as a system plan. The big contribution of the Descartes was that they showed that the geometry and algebra are 2 aspects of the same coin. Convert a shape to the equity or a equalment to the shape from this approach to calculus. Advanced geometry and analytics were all possible before the Descartes runs in the style of the geometry, mostly Euclid and Archimedes. The constructive prices with cops and straightas. Descartes said that we all shapes. The number line will handle the base approach. It was so much revolution that today we think that it was a big breakthrough in 17th century that triggered a new round throughout mathematics. In the daily life of analytic geometry, if you're tracking the witness, you plot the steps versus time graph. The essentials keep you time on x-axis and become a shape line or curve with the help of steps and coordinate geometry on the x-axis. Then you can understand the rate of change of the slope. See when steps are moving quickly from quick there are plates, and all of this is the extension of the basic coordinate geometry. When we reproduce the polygons from the coordinate geometry, we define their wards x molar pairs and connect the pair to the line segment. You have a triangle, define a 0b40c43, then you will get a right triangle. You can remove the Israeli side lenses and fascinate the area. Many of the geometry from this approach can give the theorems to the algebraic form and use them in proof or application. Then we circle the EM. We can write equalment x my a's whole square plus or minuses whole square equivalent square. If we take shapes such as ellipse, parabola, hyperbola, then all of the standard equivalents are defined in the coordinate geometry. It becomes very easy for you to plot them or remove their properties, such as the position directrix of let's rectum focus. TC is the topics of all advanced geometry, but the starting point is the coordinate geometry. So the coordinate geometry gives us a new now we can handle the shapes numerically. You can write equations about them. Their interactions can be solved and their conversions such as shift rotate can easily be reproduced. All of this goes further to our 3D geometry, computer graphics, game development, robotics, space treasure calculator comes a lot of work in all. So far we were just looking for a redemption in the D-shapes, lines, circles, polygons, and their coordinate geometry. In the next section we will put our eye on the D-volumes like cube, sphere. The cylinders and their geometry we'll try to understand, as well as we will see how we explore the real-world phenomena of non-Euclidean geometry where space can be curved like planetary orbit, relativity, and much more. The connection of the geometry moves from the D to the 3D space. In today we were talking about the lines, polygons, and circles, but in real life we see that things exist in 3 dimensions. Let's take height and depth. Now we understand the 3D shapes like cubes, spheres, cylinders. Try everything starts from the most simple D shape, i.e. the cube is the lengthy beams of every jazz of a cube, and every face is square. If we talk about the surface area, then the cube has a total of 6 faces, and every face is a square. It means if the edge is a face, area is a S, and the surface area of the whole cube becomes 6a square. For volume we use a cube formula that we can understand how much space from the cube inside is on the same distance, i.e. radius from every point center. You have this as a planet or ball. If you think how much paint is needed to cover the entire sphere, then you will remove the surface area of the sphere that occurs 4 pi r square. If you have a football and have a radius r, so you will get an idea from this formula for paint. The sphere has a volume of 4/3 pi r. The concept of the sphere in the planetary bodies is very relaxing as we look at the mean allow so let easy version is daily, such as the tube, cylinder, the cold drink, cans, pipe on has 2 circle faces, top and bottom, and 1 curved surface. If we have to talk about the surface area, top and bottom area pi r square, circle and total to pass for 2 circles becomes curved surface area 2 pisa, where the radius is in the height of the H cylinder. For volume we multiply the area pi r square and height of the circular base in pi r square. Packaging and architecture. If we see the cubes and cuboids become very common because it is easy to stake in. If you are sending a courier parcel, then the cubo box is the most. For example, easy to store columns, cylinders, and easy architecture can be yesterday. Our case spherical or hemispherical. All this is the application of the geometry, the spherical concept in the planetary bodies, and goes on a larger scale. If you want to remove the meaning surface area, you can get an idea from the 4 pi r square formula by using the approximate radius use. From this we understand how much Porsche is water, how much land is in climate modeling, how much area is heat absorbing, and much more. Now we can explore the whole D world after seeing so much. But we also have to keep in mind that our space is always that means we hurry the footings and we see that the parental lens are never interceptors and then will throw 180 degree with the zoos we come to the curved surface and the points of seeing to come out as we see the planet being negative person is, so you will think that the defenses will come our ordinance or the geographical is that we as if you're people in the surface of a zoo. The straight line isn't the default or in the footing sense. When you follow the great circle route like airplanes, stay the polar route from North America to Asia as the zone is the same concept we read in the Euclidean Europe in a geographical, so that if you pull to the parallel end, it will never be intercepted. But if you pull two parallels on the surface of the other, it may be found on one pole as landed with lens or no parallel, and it will still show you another visit on the way and converge on the poles. Curved space-time comes in concept relativity, where Einstein proposed that our space-time it can be self-addicted due to the heavy mass that we can interpolate the gravity like a solid property as the meaning has a mass. He cried a dent in space-time and he is getting object from the curvature. It is very advanced idea, but the basic notion is that the geometry can be flat but not curved. The Jess measurement of curvature is a big interesting story. Carl Friedrich Gust on Earth's surface, trying to measure his points and checked whether their geometry is giving Euclidean ridges or not. He was checking the triangle summer of angles in a manner if we had a 180 degree of the 3 angles in the flag geometry, but if made on the surface of the sphere, then the summer grade is not 180 degrees. The Gauss made the very precise tapeworments and they did not know as much on a slightly different mean, but the theory Halley presents us found in a viewpoint that we can make a curvature default for the shades and epic geometry. In matter if you go to the geometry in the detail, you can understand the concept of circle geometry, hyperbolic geometry, and elliptical geometry, the line great circles and circles geometry, the hyperbolic geometry, the space satellite. It's all non-intuitive, but then all the same concepts are essential in the relativity and advanced math. You'll also see if you head on a very large scale in real life, such as on the planetary scale, then this curve is noticeable. If you're on a very small scale, like in a small play, there you'll find the surface almost flat, as the character of the meaning is very stable. The non-Euclidean geometry does all the space ages, but there's more noticeable in our daily experience when the scale is too large, as the meaning or concept is very advanced, such as relativistic speeds or black holes. Now we've talked about the curved spaces, but there's another angle in the geometry. Transformation. Whether there is a flat space or curved, we can reflex the rotates to objects. Role of these transformations. We robotics, animations, and physics. Let's try to understand the movement and the symmetry. First of all, we think that if we shift a shape, i.e. the translation, rotate or flip or reflect, how it will look like. This approach in the geometry is very common, as we can expel from the transformation of multiple positions of a shape translation. Suppose you shift a point to the 3 units in the patch units and or axis in the x-axis. The bean's shape is just called the new position occupied. If the rotation, if you've got a round of the center point, then the size and shape of the beans will be seen. If you're talking about the transformation, just the orientation changes. In robotic arms, we calculate the same rotational movements, such as the elbow joint, shoulder joint, or wrist joint. If it comes to the reflection transformation, the magnification of the mirror image is where we flip the cross of a line. If you want to create a symmetrical design, the reflections will use, such as in kaleidoscope or in robotics in Rangali if you are a robotic arm. If you want to create the default segments of the arm by transferring rotate to the same position, then you want to move the reverse adjusting factor here. How much angles should be? All the geometry's transformation comes from the approach. In the animations, you turn a character to the screen. These are all the transformations. If you use 3D software, you can scale the object to the translate rotate in X or Z coordinates. If you have to give any reflection effect, you can define the mirror plane. All this is based on the core principles of the geometry. Sometimes we say that in the nature, if we rotate the system, the law of physics beams live or shift to time. Law beams live. This invention concept is only sitting in the symmetry, such as rotation symmetry, translation symmetry. That is what we can say that the gravity in the planet sense is shifted to the approximates working in the beams in place or reflexes in art and design on the x-axis is very important if you are creating a mandala art. Rotations or reflections generate patterns. If you're creating symmetrical designs in architecture, then you mirror symmetry use. This transformation of the geometry appears in a very artistic form, because when we transform a shape, we can check whether the shape is self-symmetric. Are there any property inventories of the shape? At the algebraic level, we connect to the group theory. On the geometric level, we can see these in a very direct way. So far, we can see static shapes, volumes, and their own transformations we're looking at, but everything in the real world changes with time. Speed, growth, ditch waves, and much more, i.e. ahead of the geometry. Now we will move toward the calculus, where we try to understand the concepts like continuous change and infinity. Module 4: Change, Growth, and Infinity. Calculus and analysis. Rate of change in daily life. Now we are moving towards an important concept, that change is changing with everything time in the world around us. Sometimes the population ever takes on money. In the maths, we do this change systematically study, and that's where calculus starts. First of all, we try to understand the rate of change from the daily exam. The most straightforward exam is if the car's speed is when you're running a car. You see on your speedometer to see how many kilometers of age are going from at a kilometer. This speed tells how fast you're covering distances. If you increase speed, the rate of change increases, i.e. you begin to decide more distances every second. If you're stuck, the speed falls and the rate of change decreases. See, in banking and finance, we can study the interest growth. If you feel a few percent interest on your money, the money is growing from a certain rate. The rate of change in compound interest becomes even more, because you are also making interest on interest with the principal. This idea is very family, that we say after a year the amount will be so much. Behind it is a continuation of growth. Population change is also in this category. Let's come up with a city or the population time of the whole country, or sometimes less. If we track the rate of change of population, we can guess what synchronization will be in the next 5 years, 10 years. This is essential for playing. If you're using a fitness app and watching that by 10 p.m. you've had 1,500 steps on the morning, then 2 p.m. saw the totals be 3,000 steps. You can think of what the rate of change is. How much I found in so many hours. Sometimes you run a lot of steps in the same hour, i.e. the acclimated rate, and sometimes very little, i.e. the low rate is the rate of change of speed. If we talk about the interest rate, is the speed of the amount that is increased by the speed of your account is linked to the derivative concept. And if we see the acceleration and the speed rate of change is how fast change is happening. The acceleration is another real life pointer if you are looking for the speed of sitting in the car. If you press the accelerator, the speed is increasing. The positive acceleration will show that the pedal leaves on the hills, the gravity accelerates, and we become faster. Derivatives only quantify all these things, how speed is increasing or falling from the rate. Just understand that derivatives in calculus are the formal tool for us every type of change, whether it is a speed population or a variation in a temperature. Now we are taking this concept introducing. Go ahead. This is the basis of the idea integral calculus of this session. If we take the exam from daily life, you are budgeting whether you take 5,000 subs for 1,000 rent for 1,000 bills for groceries. That's why in the approach continuous version we take the area under curve or total distance. In the travel, let's say you're running a car and changing with your speed time, ever at 30 km/s. 60 times 10. If you want to remove the total distance, the speed at every short time interval is multiplied by time. You get the approximate speed, and in the limit we can remove the exactly distance. That's the idea of integral. Gradually the radius of rectangle becomes so small that you remove an aggregate integral ridge. Archimedes were using this approach very long ago. They removed the area of the circle. For the circle's map polygon and all the small parts were summed up by Newton and Leibniz. Further formulate this idea that we read the modern integral calculus. Newton developed both the differentials and integral calculus to understand things like planetary motion, gravity. Leibniz noted what we show today from the sign of S. This is the sign of the integral. How much we do in real life. Total distance, total cost, total electricity bill, total water use, all integral concept. Directly links may occur if we plot the function such as speed versus time gives its bottom area total distance. If the current versus time is graph, then the charge can be accumulate. It is a universal approach. If you do that, you are driving from one place to another and the speed is different in every moment. If we plot the speed time graph, then the distance is glued to the area below it. It is very logical to think about the mind, but maths have formulated it in the form of integral. Archimedes, Newton, Leibniz, how they different paths from this idea developed and then used to deliver the entire physical world's laws. We can understand if we have to go deeper. When we understand that calculus is not just an illustration mind, but also a practical problem, i.e., planetary motion, area of irregular shape. We have derivatives, i.e. rate of change, and integral, i.e. one-time intent is now another consignment that many people are faced by. How much of the infinite series we find infinity viewing. Paradox acting fractions, decimals. Let's try to understand this process. Infinity is a term that can make us look a bit philosophical, but in the maths we handle it in a very systematic way. First of all, consider Zeno's paradox that if you are always covered by half distances, you can never reach the goal. In the paradox in Fanisil we see that the infinance's music will continue to move. We think that every term is going to be short. How much the finals will be the same and the middles equal to the actual one. We say that the deck series converge once you add an infinite. We also get to a finite value. This is a mind-blowing thing. Our brain should have a separate mechanism of handling the infinity. If you talk about reading decisions, then many times we see a decimal repeat in the fraction like 1/3e 0.3333 and so on. You can write infinite 3, but it gets reproached from a finite fraction. All this is the exam of the infinite process. You see fractals as you will take a shape and back the shape by zooming every segment of it. You will find the similar pattern at every level by the infinite levels. This allows us to learn a lot more in the natural patterns in case of thinners. People from Zeno's paradox thought how we rejuvenate this. Calculus said that you add the infinite steps to a limit. He gives a finite value, i.e. if you will always cover half of the distances, then even after the infiniting steps you get to the final point. In the mathematically speaking real life you're building a physically distanced tree. In the aggregator, he gets complied in the finite time. If you look at the fractal geometry such as the pattern of branching in the tree, the jagged shape of the fuzzy edges coastline in the cloud. All of this looks like the fractal infinite complication, in case that you have to ensure the butterfly effect. A small change in the finite series may be as amplified, i.e. the infinity appears in or around very forms either in the geometry or in the dynamic systems in the mouth. We have this infinity series in terms of convergence or divergence. Classify will make a series converge if the finite is the same. Diverge will ever increase or oscillate. All this further comes in real analysis, but for now, understand how derivatives in integral as well as infiniting, i.e. derivatives acumen, i.e. integral. In further section we will try to understand all of these concepts in a more rigid manner. Analysis will bring tools and glimpse how the real world is applied in phenomena, i.e. physics, engineering, biology. Calculus just an extract. Exercising is not the language of continuous change that we understand a lot of dynamic processes of nature. Now from gravity to fluid flow and wave motion, all can see the hand of calculus. Some exams see how the concept of differential units and dynamics runs in the real world. First of all, we talk about gravity. Music Newton. When his law of gravity was proposed, his math foundation had calculus planet lives in a continuous motion. He follows orbits like if we defend the position of the planet with time t, i.e. that sub t and w of t of the rate of change of those ordinance is distorted from all the differential units. But if you think that people in the previous century were indecisive about how this orbit is become and so perfect, Newton said the force equal is nested acceleration pulses the gravitational versus variable in calculus, and you will be the organization of orbit fluid flows in other domain when you see water flow, air flow, or any chemical somewhere. Changes if we are defining the stream velocity, pressure, and density. The relationship between them has been captured in very advanced different equipments, i.e. Navier-Stokes equipments. All of the calculus bases are where we analyze the rate of change of motion of every small fluid particle. Fluid flow in pipeline design and aerodynamics of planets and weather forecasting is the relaxing everywhere. We can take the exam for wave motion, vibration, differential equilibrium. The wave or string of the symmetrical is the same different time. What will be the speed of how the wave will shape and how the amplitude will change if we plug a string will silly, and we can model this as from a wave equipment. You see in the physics that the IN is derived from the derivatives of the displacement in the second derivative time respect of the tension, and the linear mass density factors were just turned out to be your wave equipment, and all we see that the calculus tried to bind us to the dynamic processes of the nature in a single framework. Off continuous change means that you take any continuous phenomena to put it in the different equipments, and then we also call the dynamics because we are not just static position but interested in the changing position or changing condition. But as we see in the real world, every phenomenon does not just dip on the same variable. Many variables are changing together as the temperature, pressure, humidity, and the humor is all. Now we come into the multivariable calculus, where the diversification is in the multivariable calculus. Gradients play the largest role. Multivariable reality. One thing we all know is that everything in life is not a solvent from a variable. They carry the casting itself. The temperature is a variable on the pressure, humidity, wind speed is all the different variables, and all the time are changing with location in the space, i.e. we got multiple input variables and we are outcoming. That's why we penetrate into the multivariable calculus, where we try to make the mutual derivatives gradient and a surface definitive. If we take a function f of aqua z and so on, we will see the rate of change in the respect of x. We can see the rate of change in the respect of yz. In the respite of this way, we can understand what is the key to the function in different diagrams. Gradient is a vector that points you toward the fastest growing direction. Let us know from gradient in which direction the most temperature incurs. This is a very work thing in the weather, as you can see that high pressure regeneration is coming from low pressure regeneration. 3D surfaces we can't define on the D plane for the exam if we do the altitude defining. You can keep a height h for every x command location. This gives us a surface. Graphically it can show in 3D. If you think in the city planning, then how is the slope? The drainage will flow. All this is dip on the gradient. What is the rate of change where another curve is the temperature gradient understanding the direction of the wind will be the results. NASA is through all damn agencies when the satellite data is taken and their analysis is happening from the multivariable calculus itself, and not just the way 3D model may do in the stuff are variant sy and z coordinates of objects for defining the transformations or imposed at the moving or curvature in the shapes is the only solution for the mutable derivatives when we see. And there are in finances we need math's fundamental tools, i.e. limit, continuity, uniform convergence, all. That's what the domain is called. Now we get into the rest of calculus, which is the analysis, and we press the concept like limit, continuity, and uniform convergence and derivative integral, and finds an advanced analysis so that we have a solid foundation to the limit we define at what is happening to value of function behavior as no matter the value of likely derivative sounds. We do a limit approach to slop extract. Continuity ensures that there are no jumps or breaks in the function. The small change in input makes the continuity a lot of sense in the output physicals. We aegis that the nature consists of the abruptly. The quantum level can have an exemption, but the continuity in the classic sense is the rule. From the uniform convergence we handle the infinite series as we ensure the concept of the scene in finances that we ensure that we like operations in the series. Integration differentiable with missing up results. Mathematical rigor comes from all of them. The first ones seem to simply derivative and integral use, and all will happen. When the Deeper paradoxes came out, the deficiency in the analysis and the proc of Allen delta prumps began. This is the regeneration that today our calculus provides so stable frameworks. In engineering we build large structures. Rigidums could flow into design if the base of our calculus is weaker. The analysis and everything from things error-free created. If we want to keep our scientific and engineering resumes stable, then we design the numeric methods from the analysis-based approach, i.e. you calculate a rocket trajectory, follow a simulation, and train machine learning models everywhere. Underlying math has the principles of the analysis that guarantees that we can bring the solution from the incremental step, and the final result will be the consultant. we handled the concept of continuous phenomena and infinity, but there are also plenty of uncertainties in the real world. We step into probability and statistics, where we will talk about answer in events. Module 5 Insertions Desert Making Probability and Statisticals. The concept of chances. If we look at our daily life, we will see the role of chances, i.e., probability on every side. Sometimes we discern the cricket match from coin toss. Sometimes there are hopes from the lottery ticket, and sometimes there are no exams about what is going to come on a thin line between the lock and rounds. Is it all take the coin toss, the most straightforward exams to heads came to the tails. Both have a 5,050 chance. This is the coin fair with Ajman, but people sometimes think of 2 3-bar heads that will now come to the tails, while probability-wise is every toss independent. If it comes to the lottery, there is a chance in a million that many people out of your number relay it from the lock. In the mathematics, we say that the probability of the outcoming is very low. You don't expect you to win. From this idea, we can think of the daily desires why we want to a lottery or retirement planning, as the odds are very low. Casino odds facet. A lot of people. You blackjack, roulette, slots all have probability. You must understand that there is a house edge that stays in the casino profit in the long run. People think of the lock's tricks, but maths say that your average negative will remain for a while. This understanding will save you from the impulsive betting in real life, or even if you do, then a test, you know what is the expected outcome. Let's say you will play the slot machine. The casino has a chance that you will win a jackpot, but the chance is so low that you will lose your budget when playing for a while. That's the random. Sometimes they also turn to leave a single in probability, we defend the proceed and let the probability of the event, i.e. may alive in a way they seem, but randomness is how we get rid of the hapless. Now, the betting on that, learn the method of memory, and learn the music uncertainties. Majoring uncertainties. We say, I think it's rain today. It's an idea of how much percent chance. We've seen the news channel that over 70 of rains, it comes from where the figure comes from 70. To find the answer to this question, we've made probability systematically. Learn a basic approach to the frequency, where we see how many times an event did in the trails. Like if we do 100 times the coin toss, and we can say if the heads came 52 times. They approximate probability of heads as 52 by 100, i.e. 0.52. As we do trials too much, we try that this relative frequency stabilizes and becomes the same probability. In the real world, we collect data such as how many people are using the seat belt while driving, how many we do not, then we probability and risk assessment on probability of wearing seat belts. As comes to work, insurance only runs on this entire concept. Collect car insurance, collect health insurance. The company takes premium from you. He calculates the base on what is the probability to get an accident or claim. If the probability is high, then the premium will be higher. Similarly, in the investments, you see the probability of stocks, how much the chance is of profit loss, and how much the expected returns. All of this majoring music uncertainty value is a very powerful consignment. You are buying a lottery ticket 00 that does not have the probability of your winnings by 1000, and you get 00 when you win. You can withdraw the exclusive value of 1 on 1000 multiple Bs, i.e. and mean tickets at Thorites 0. Galling strategy has a lot of work. People sometimes put a large amount in a short-term excitation, but they don't get the realize that their expedited value is negative. If you want to go to the details, then you'll want to go to the details. Galling strategy has a martile system or card counting, but you'll notice that the house has such an advantage that the long run fails to most strategy. It's all the law of probability. While anything in the short term, the law of large numbers say that the events will come to the Everest. In the real world, you can risk and probability in life's big dissipation, meaning majorings make dissipatives by understanding the uncertainties. We just understood to uncertain with the help of probability. The next step is to see how it appears in the distribution patterns of probability when we collect real data, i.e. Pisces variance, and a number of distribution SIPs such as distribution and extraction. We have to spot the pattern when we collect data. Is data sprayed all the way? Is clustering in the middle? Is a tail long? We look at all of these distributions. Distribution basically tells how much every possible outcome is doing with probability or frequency. Whether we can show a distribution pattern of the test scores take out to the daily temperature. You see the common exam that is Pisces, i.e. average. If you take a distribution of test scores, the average might be 70 out of 100, means if we add a score of all the students and divide the total student, then the average 70 will tell how many scores spread out. If the variance is high, means a few very high scores, some too low scores. If the variance is low, the mean is in the same range close to all. The normal distribution looks so common because a law of phenomena gets the data centered around Pisces due to the central limit therein, and the tails are extended on two sides, such as the high distribution errors in measurement IQ scores are all the approximate solution cymatic pis and modes remain at all the same point. We have a lot of error in Asia whilst hypothesis testing etc. forward. We'll try to understand that in the exams we can take daily temperature if we collect a one-year template of a city and create a histogram of those values. We'll look like a vine or vine. Temperatures in some yards take a lot in many yards, but in most yards, the test scores of narrow average students can also show you the same patterns. Distributions are not the same type. Sometimes there may be a SQ distribution where a tail can be long by models where there are two pexes. All this depends on real data, but PIS-wise, and sometimes there are standard navigation i.e. SDR basic tables. To summarize the data, you say the average of this course is 70. Standard depression is 10. This gives us a quick sense that maternity students will be between 60 to 80 i.e. plus minus 1 AD. This approach allows us to see the high dishonest distribution of people. The return distribution in test scores finance everywhere there is an idea of how many outlooks the data is getting centered. We normal in probability theory further logs from distribution. Normal Poisson Bono can read all possible distributions, but it is only that data's possible outcomings and their probability are to be deleted. Now when we have understood data and distribution, how to analyze these by collecting real data sets, how we transfer from these distributions. The next section will talk on the data collection, representation, and status infer from which we can inform real-world discussions. Now, where the data comes from in the virtual world and how we gather and reproduce it. You start with the concept of the sample and the NAP. You will find that we can't be able to analyze the entire population in real life. The number of people can be so large or the list of data points can be so long that we just have to work with the sample and then we like that it reproduces the sample population. If the sample is unbiased and random, then the survey is an authentications to collect data. Studies send a lot of common approachables like sensors, feedback forms, customer setupatry can be missed by people who don't have internet access. Actively set up some condition like group A to medication, group B to plus CB. Then outcomes offer you random assignments, thereby reducing external influences. In observational studies, you will be able to track any of the phenomena as a way to live in a wildlife. Recording cities' traffic flow isn't a control like the expiration. You can capture the large-scale, real-world patterns. The visualization tools are the first step to understand data, such as histogram. If you have to know what range of data is getting the most clustered frequency, the histogram becomes very intuitive if your test scores are 0 to 100. You can create 10-point intervals from 0 to 10 to 20 to 30 and so on, and every bun. You can immediately understand what range of people were scoring in the Saturn comes when we multiply two variables of the same sample as we put the height and weight on a group high asses pay the way every data point on asses will deliver the human height weight report, and we can quickly judge from a scatter plot that there is a relationship or all random. If the data points form roughly a diagonal line, then the relationship to the strong is out if the spread out has a relationship weak. All these visualizations lead to clarity. You may be confused by seeing 10,000 daily in a CSV file, but the histogram or scatterplot helps to spot the pattern at a glance. A lot of software Axel Python libraries can generate RTC very quickly graphs. It will be your skill that there is no outlier in this histogram to find out what is going on. The scatterplot has become a data gander, and we have the next step to try to understand the overview by making a basic visualization. Our indent, i.e. how we can get about the complete population from the sample. For this, we bring the status efforts tools. You've collected the data on it. You'll have a goal that can make certain claims about the entire group's entire population. If we surveyed just 1,000 people, we can speak for 1,000,000 people. The same physical concept is that over to very word post and with intervals to put this setting to the interval for the many you equal var simple pussy ram puppy from pussy from you var 1,000 people with simple the average 568 of the 7 puppy from pussy so we ran with the murder of you see evidence for the murder of here and plus of view the real sort of plus of stories firm of each to the interval. If we are calling confidence at 95, we are speaking that if we take the sample very often, our interval plan parameter will cover in the cases at 95. In the hypothesis testing we take in Python, i.e. TAP hypothesis such as this medicine's effect is 0 or 10. There are no defenses in Team B's scores. Then we analyze the data to see how much strong evidence is in the data. To regain this hypothesis, if the strum was found, we regain hypothesis, i.e. we say the effect in medicine is defense. TC here is a number of ingredients that are how much the chance it comes from just random fluctuation. If the value is too small, we say real significant is a formal label that we understand that significant is a formal label. A statistics on the not an absolute trough from we disassemble how undisposal to observation. This approach is very common in medical trials from the perspective of TAP hypothesis. testing a new drug by revisioning a group of medicine to a group. Then we see the defenses in the outcoming and hypothesis testing, whether the defense can be just from random chance or the medicine really helped. A/B test is digital marketing, and the design of a web page in the software is performing a beater, or the design is B. In it we roll out the mutual role. Major convergence rate. Then what is in a candidate lead in hypothesis testing, political polling, or both in the almost tie, but in all we think of conceptually. Engaging about populations from sample data. In this approach with a margin of error, we show significance from very systemically uncertainties and estimate range from confidence interval. But every data analysis also has pitfalls. Misleading graphs, overfitting to relation versus connection. In the next section we look at these real-world applications and their pitfalls. The media headline science article is how to keep alerts in all of us. Music should headlines in newspapers. Coffee easy for health, coffee is bad for health is a beneficial one, harmful sometimes you get condensed. Because gives two different study contact results. Here is a major thing to understand: correlation versus connection. If we see in data that people who drink coffee are health outcoming, not necessarily coffee can be direct cause. Their lifestyle exercise is different from heavy bits or genetic factors. Many media articles have a different relationship. Causation as a result, that is a big pitfall. Overfitting is another problem. Specialty one will be nudged instead of a complication in AI/NM. Then the model fails when new data comes to the simpler statisticals try. Any combination will surely exit the signal, but it's the sperm in the virtual. Misleading graphs media is very common. Manage access, zoom the scale and show the relevant data. The viewer gets wrong impressions, so critical thinking works. Samples sizes can check data. A source can sometimes contain colors or side disproportionate in charts. Sometimes the pie charts will distort. All possible is the electricity. Data addicts has also become a big convergence in today's deposits. Privacy issue, bias data sets, manipulated results. Company wants to show the results in our favorites by ever highlighting data, or in social media platform user is analyzing the sensitive data user. We have to take care of these pitfalls somewhere. We unknowingly do not spread the disformation. The critical thinking says that when we look at a new study, new claim, or a new chart, we asked a few questions about what the sample size was, revision or not, to see the relationship itself, or is a virtual mascara study. What is the effect size? Data never lie, it is a myth. Data can be misrepresented, mis can be read or lateral, so we always have to check for contact and method. From the statistics we learn to handle and ascertain data. Now we will try to monitor the structures of deep mathematics such as abstract algebra, topology. From where we can jump into cryptography, advanced geometry, and even multiple modern applications. Module 6: structured in deeper mathematics, abstract algebra in modern structures. If we take a building understanding to the mathematics, abstract algebra is a high level where we focus on structural thinking, meaning we have now seen the numbers, equalment, sets, probability. Now we are going to make systematically differentiating the roles and aims behind these things. Sets, groups, rings, and fields are all the structures that have completed above. Modern mathematics works up to physics and cryptography. The most basic concept starts with which set. You've already heard of the collection of elements where every element gives us the distinct identity. On the concept of sets, there are only group ring fields such as algebra structures builds, defining their roles, i.e. operations. We take a level and abstraction. What is the group ruffle? This is a set above which we've done an operation like emission or any transformation, and that operation can be applied between every two elements. The condition is that the group has four adjoint satisfied closures, associative identities, and events for exams. If you take the institution with the addition, it becomes a group, and think in the syntax of the symmetry. Put all the rotations or reflexes of the Rubik's Cube in a set. Define their composition. You get a group. This allows us to study the translations in a group in physics. Rings are a step forward where we have two operations such as additions and multiple options. Under close is the integers ring. You add them to multiplier. You can handle all negative numbers in the rings. This is a very fundamental structure. Polynomial rings, matrix rings are all used in very advanced medium. The field is on another step where you have the addition subset, multiplication, division by zero, subdefinition, and whole all the adjoint real numbers, i.e. rational numbers, i.e. kaya, and complement factories in the field. Without all you can do, coordinates, geometry, linear algebra, and calculus are all very difficult. If you want another detail, you go with the theory or the show that we can analyze the solutions quickest solutions are possible. In other words, show in the watermelon zebra. In cryptography, we are using the structure to date. Finite fields group based inscription CTC symmetry. In physics, if you want to see no iters, theorem shows that every continuum in symmetry are associated with the conservation law, i.e. if the system is rotationally centric, angular momentum is conserved. It comes from group theory only. In the similarly cryptography, we define group operations. The thing we understand to create a secure communication is that we are not limited to numbers in abstract algebra, but we can take any set of elements, whether transforms or matrices or Paulino bus, we ensure that follow our defined operations executives. That becomes a very general framework. Now we try to understand the concept of structures such as groups, rings, fields. Now we will look at the vector space, where we can do very powerful manipulations in D3D and higher dimension from linear transformation. AI graphics image processing comes from your field as the vector space, and linear transformation vector space concept is very central in modern math and appliques. When we say vectors, you think usually arrow, which can make magnesia. Scalar comes from your field as if you think of your field. Real numbers, i.e. if we take the field of real numbers and draw it on that, it sets the SK multiplication and editing, we create a vector space D3D geometry. This is just the tip of this. Vector space is in finers like function spaces matrix. This is the most practical form of redefinement of vector transformation when we make a linear transformer such as grayscale conversion in image processing or scaling. All can be from multiplication of a matrix. You can be a 2 by 2 inda. Use 3-bit matrix in matrix 3D and a bi matrix in the bigger appliques. We multiply on the data, i.e. vector, by defining this matrix. In the D modeling, you reproduce the volts of an object into the vector form. If you want to rotate or scale, you make a matrix defining so that every vet is multiplied. The complete object is transformed. In the same machine learning, you reproduce the data points. High-dimension vectors are treated in the form of matrices, i.e. weight multiple neural networks are the chains of basically linear transformations plus non-linear activities. If you take an image processing exam, then a digital image in 2 grayscale is RGB Ramaji earned 3 values in every pixel. You can multiply a matrix such as 3.59111, a grayscale intensity will be found. All this happens in the vector space. Pixel S vector transformer S matrix. This direct application daily smartphone filters can see all the space in photo editing. The strength of the vector space is that we apply linears where all the coherent remains in the addition and scalar multiplication. That is why the quantum states in advanced physicals are reproduced in vector space. PD solutions are searched in function vector bases and can treat portfolio returns in vector notations in finance. This linear algebra structures are not limited to just geometry or graphics. This allows us to secure communication data. Integralities also help in things like integrality. We'll try to see what is the real world of cryptography and error correcting codes. Appliques to coding and communication. You think how much data we're sending to the daily digital world every day. Emails are ongoing. The concept behind all of this is algebra's own concept. Cryptography, error correcting codes and encoding. If the cryptography is done, RSA is a term like elliptic curve cryptography. It contains all the group theory ring structures and finite. It is not possible without fields. In the cryptography of public, we are the pillars of prime fav modular armamentsdrive algebra. At the ellipticer, we make a group of points of current and generate secure from the operation on it. If the thing is to do working codes when you receive the satellite data or receive a tough stream, the network error may come to in error correcting codes ensure that if some bits were tassated, we can detect and perform them. Read Solomon-Henning codes LVPC are based on all field operations. We do data encode by defaulting Paulino. This allows us to reconstruct original messages from the relevant data. If we do this, we map data into a structure such as SC Roman 2 codes for characters and advanced form for compression. Algebraic approach, we can ensure that we can decode maximum compression or reliable in digital security. If we use prime factorization, then it is difficult to factor in large primes that we do from group-based inscription we do. Secure channels can create bank transactions, password login all in today's deposits. When it comes to quantum computing, people are expanding new algebra structures, i.e. lattice-based ETC for post-quantum cryptography means abstract algebra constantly is happening to keep data safe in future threats. Satellite data has a considerable error correction. Suppose you are transmitting images and sensors in space mission. There are errors that the mission's data may worsen, but the advanced codes inspire that we can remove the accurate results from the imperial or noisy signal. If it comes to the real-world executive, there is a NEF error correction when you're streaming a video. A lot of data packets have a video split. Every packet has error correction bits dead so that you can freeze your video without having to recover the intact frame. We've tried to understand the abstract algebra and linear transformations. The linear transformation has given us things like secure communication and raw data streaming in the real world. Now we will focus on another absolute RAM, i.e. topology, where the rubber sheet of shapes and connectivity is studied from the geometry angle. Intuitive topology. So far we saw sets, groups, and algebraic structures. There is also a next level abstraction in the geometry. Topology, also known as rubber sheet geometry. If you can pull a shape like a rubber, then there is no tear or glue up. You can see which of the essential property are something continuous deformation of say, but you can deform a Huffy cup then into donut as both of them have the same hole. The main focus of topology is on connectivity, how many of the holes are in shape, how much the disconnected components are, or the lines KC can now leave the angle, distance, or curvature of the geometry. Atlas basic topology. We see the whole structure of the bus shape. Coffee cups versus donut example is the most famous. The handle of the cup is his hole. The hole between donut is his hole. Topology. Both beans have a sphere and donut topology different because no hole in the sphere is a hole in donut. In real life you can see maps and networks from topology approach when you look at a London Underground map. It doesn't have a scale or angle effect match to the lines and their connections look. It is a topology diagram. We just need connectivity in the network topology of the internet. We show links between nodes and agencies. Connectivity is much important if not a distance effect. Another good approximum is that if you are not a contact, GPRS i.e. mobile data networks are checked, then you can have a path length speed subsecondary. Just you want no breaks that are connected. In topology we can systemically study this connectivity if you want to define the boundary in this shape. Just as how many cells or loops can be in a regeneration, all of them are out of topology invariant. Rubber sheet can look at the geometry daily life where we do not matter more than scale, angle, or shape. Just let us pay attention to connectivity. Transport maps, circuit diagrams, wires crossing versus not crossing, social networks, friends of the friends connections can interpolate from all topology view. This allows us to understand the shape and connectivity at a very minimal level and a strong foundation for advanced math. We had to understand so much in this section that holes and connectivity topology are very matter. Now we will talk about manifolds and higher dimension where topology plays a NCSD level role in things like relativity, black hole, string theory. Topology is not limited to just donuts and coffee. We can also talk about multidimension surfaces that we call manifolds. The manifold basically is a shape that can seem logical flat or locally Euclidean, but that globally can be a curve. Spherical surface is a D-manifold that aggregates 3D space. In the relativity we call space-time as AFDI manifold. The basic thinking of time plus 3D space dimension is how many independent diagrams you can move in D-plane. 2 directs 3D in D-plane. In the space of anything the 3 folds for the design and hard to the living know the layer from the FE8 is folded rather than but since a very fundamental. We call flat space-time as Minkowski space, and if there's a mass or energy, it is a curve that we understand the gravitational effects. From the curvature we can define how much manifold is bending as fire's curvature positive. A settle shape may have negative curvature. The field Equaman essentials of zero curvature. Einstein in plane says matter energy distribution curvature defines curvature in black holes becomes very extreme where the light is not able to scoop. All becomes very interesting from topology and geometric viewpoint. Sometimes manifolds may have a hole-like structure such as wormholes or boundary condiments define. We try to understand that the fundamental particles one day strings as they do and their vibrations lead to mass charging properties differentiates. It comes to positivity that the shape of the 6 extras compression folds can contain extra loops or folds. But on the macro scale we don't see it all goes into very advanced physics, but all of them have the base in the roots topology and manifold table. We can't see direct, but we work with production crosses and analogies such as a cube shadow inda. If you can default a teaser act in 4D which is 4D hypercube is depreciated by the projection. It can be mind-blowing, but in the concept we are just a dimension and add topology gives a systematic method. We tried to understand a basic role of topology in manifold and higher dimension, how big it is to be a black hole. The next section we will see that this topology thinking we have data analysis brain. How to put in real-world problems like connectivity and advanced robotics. So far we saw the therapeutic side coffee cups, donuts on manifolds, curvature to topology, data analysis i.e. TDA is an emerging field where we are looking for clusters or patterns in compact dimension. Data sometimes fails linear or standard clustering at topology approach. We see data as a point cloud and its shape and hulls. We identify how data is like. We sometimes get deep insights that miss standard methods in network topology. We can see how neurons are connected in brain or how people are connected to each other in social networks. In brain connectivity we can check with topology majors how many loops or all networks are formed. Is there a node too central? Is there any region islet happening? This advance is running a lot in neurosciences. Kinectons. You think in robotics, if a robot moving into the environment can make or possible confine a manifold, i.e. from the confined space topology analysis we can take help in path planning or collision avoidance. Shape-based data classes are also very interesting. In no imaging data, we are editing shapes such as the inbound topology approach of tumors in medical imaging. We can edit the halls of the bastion. Shapes can be compiled and classify or animal detection. Sometimes the intensity fluctuates to manifold in local geometry. The TDA real appliques are becoming very popular in this way, whether it is a gene expression data sensor networks or the exam in the iconophysis data. Advanced robotics is that the possible positions of a robotic arm can form a very complicated manifold. An angle for the anti-joints makes us a high diet space called confined space. We can plan the topology path to armament the collision, which is a free regeneration blocked, i.e. rubber sheet in the geometry sense. We say we will find free paths or not all that is connected with direct topology thinking. Now we will move from topology thinking to mind and advanced analytical tools, i.e. the complex areas we will try to understand. Fluid flow, electromagnetism, quantum mechanics, and how our advanced mathematics unify all real-world phenomena. Advanced analysis and BID's complication unit is where the square equivalent 1 is the first thing to do is quite unnatural. Is the square root of negative number logistics can end up slowly discovering that in the complication we can collect very powerful mathematics by defining real axis and imaginary axis. It has a lot of appliques in the area such as complication processing music. The number is written in the basically APSBA form where there is a and b real numbers. You can treat it as a point in the D plane. Addition, multiplication is all very intuitive in this plane. Can be effects like rotation and scaling. From imaginary unit I we handle negative square routes, but you will see that a lot of space in engineering and physics. These two-dimensional number systems are most suited, such as defining wave faces in AC circuits or combined sine cos with ease power at the wave equipment. The analytic function, i.e. the holomorphic function concept, is quite interesting. If a function is differentiable in the complication, then its behavior becomes very contrasted and structure. It meets very good identities such as cos integral formula residue theorem etc. It is very common in all engineering. If we see d flow in fluid flow defined, then navigate into the complication and can analyze the variably velocity pressure fields. Wave superposition gets easier from the complication when we put in waves in electromagnetism in signal processing. The Farad transformer is the base on all the complications. You can call the ERS formula as a conspicuous wonder. The power of eta equivalent cos theta point of sine theta is an identity that we unify the sine cos expo essential trio. If you put the beta, we get the same. The power of pi p1 equals 0 of this ERS identity is a mathematical poem. It shows that the circle trigonometry, i.e. sine cos and expo, are all combined. We tried to simply the complemented flows all. Now we will move a little further to the PDIE, the traditional equipment, where we bring multiple variable advanced modeling and functional analysis so that we can handle the compliant phenomena of the entire reality. The functional analysis PD and modeling reality, you think we are a wave equipment. We're not on variable but on space-time. Sometimes we're defining the velocity field in the fluid flow, i.e. the velocity vector is different on every point in space and the change is also happening with time. Here we model from the traditional differential units, i.e. dd. Yes, the multiple interpersonal derivatives of a function are different. It looks at all from PD's classic physics to quantum mace. Waves, heat flow, electromagnetism can be expressed in gravity sub-PD form. Functional analysis. A level of this thing, and we see what the effects of linear operators in these finite dimension vector spaces like function spaces, what are the eigenvalues of operators, etc. means you can define an operator that maps the function into derivatives or as a wave operator. What is the solution of the operator? What will be the effect of the boundary functions becomes very crappy. Only from this approach, we have been using PD's solutions, estancia evacuation solve. In the weather forecasting, we are in approximates. Let's follow the operator's properties analysis routines. Waves, heat flow, quantum mechanics. PD basted is the temperature field in heat equipment. How is diffusing with a single ZT time? Dissipation in wave equipment. IAT how propagators are or defining graduating equipment in quantum. PD solutions in the wave function real world of particles. We use weather forecasting has a Navier-Stokes equipment approximate making rain temperature wind speed all models medical imaging i.e. MRI CT scan. It contains PD based reconstruction usage where internal structure is deduced from wave signals and boundary data computed topography. Basically PD's versus problem solves it all in functional analysis and PDs. Now we have tried to understand a lot of aspects of advanced analysis. Compaction analysis at introductory level. Now we take a look at some of the frontier of mathematics. tightening the freshness machine learning unsolved problems where today's researchers are running the frontiers of mathematics. Now we come to the areas that today, math's frontiers are called, where researchers are putting lights and have new discovery possibility every day. Starting with case theory. This idea says that some dynamic systems will be very sensitive on the essential conditions that long-term prediction impossible. The butterfly effect you have heard. This is a butterfly wing flap in Brazil. So in a storm texts, the system's equipment can be deterministic, but they can be very unpredictable as the slightest change becomes very amplified. At the same time, we see the whole PDE regulation on the long range of error blew-ups. Machine learning is another big frontier. You can see deep neural networks, reinforcement learning, and Bayes methods. This solution can bring a lot of revolution from cryptocurrency to number theory. In the Nevu stocks problem, we are not yet to be sure that the solutions of these PDs are always ageist or can be blew-ups. That question in the fundamental of fluid mechanics. The versus NP is a great question in computer science. Is there any of the problems we can do quickly verify? The solution is quickly fascinating or not. In the fractal geometry you see odd shapes, Mendel broad set fractional dimensions, self-similarity. You're trying to interpret the coastline, clouds, mountain range, subfractal in nature. This is different from the geometry normal Euclidean, where there can be a dimension fracture. Connecting this to the low case theory to the climate patterns, hurt rate variable, stock market flickerings are all trying to interpret. Quite research is now ongoing. Math is an ever-evolving domain. Now we all think we've come far away. On daily new discoveries come with new methods. You'll find as much as you get into the mathematics that have an ocean in which you've just been looking for a 2-drop. Do you know that you can solve any of these fractions of the solved problems, or proposing a new domain that gives the next generation to the highway? Many think that it's a growing force, new branches with physics, biology, computer science, economics, and social sciences all in the module Sen reflexes, and putting it all together we try to understand in this whole video. That's where the journey of math starts and how the advances reach the topics we reach, the simple mitosis and calculus. If you take a step back and look at the entire panorama, it's obvious that mathematics isn't just a game of numbers and units, but a way to think is a perfect that deepens our understanding of reality. From Ehrman's geometry we learn the logical, regenerating, systematic thinking. Then algebra taught us to deal with variables and so that we can express real problems in the general form. Calculus quantify the continuous change for us. The rates, integrals, infinite processes all come into a unified framework. Probability and statistics taught the handle of randomness and uncertain data to bring us proficiency in risk assessment, decision-making, and scientific excellence. In advanced structures such as abstract algebra, topology analysis showed us how we can do their intensive studies by isolate pure patterns, and from those patterns we design cryptography. Advanced physics free brings this journey, pushes both logical and creative thinking. Logical so that we follow proof, thermos as those rigorous definitions. Creatives because we also use mathematics to invent patterns, spouting lips of into in new structures. Whether resettling in real life, you get structures in methods from budgeting, design, research, or any invention mathematics that you can systemically address the problems. A big theme of this entire journey is interdiscipline maths. You can find structures and methods in every field. Gateway providers: physics, chemistry, biology, economics, social sciences, computer sciences, art, music can get all the features from mathematical thinking. You learn to see patterns, models, century data from all angles that change your eyes. Mathematics tools have become very powerful. Machine learning, big data analytics, cryptography, PD modeling are all disrupting the real world. On ethics and data privacy issues are beginning to come up very sharply. If we advanced analysis of all people's personal data patterns, if you take to do, privacy risk can occur in cryptography. We can keep data secure, but if you crack the quantum computers, all secrets can open. In AI responsibility, we think that algorithmic bias, job dissipation, misinformation can be all side effects. Limits of models should also remember us, whether there is climate modeling or AI productions. In all, we can't take the simplest fractions in real world bucolic or completed or perfect essentials. We are indispensable. Best gestures can never be at absolute. Sorry. That's what we read. Probability and statisticals. Uncertainties connect with social impacts from productions. Policy, diseases, resources, locations, medical advice can be all model-based, but if the model goes wrong then the conceives can be very large. So in mathematics we think that how the model is validation, transparent, low how is stakeholder outreach, how any AI system brings the bias in police surveys, then social ingestion may increase any climacine model. The policy can be missteps. Yet hope is that math gives us critical thinking and informed perspective. If we channelize this power, we can create sustainable solutions, fair data uses, and truly beneficial AI. All this is dependent on the minds and hearts of real people. Math is just a tool set. How to use it in our hands. Just for today, we will find it again. Thank you with a new topic in a new episode.